You have not understand normal questions carrying to hypergeometric. Take Gary. This is the basic stuff you have to understand first. Let me see it. Maybe I know that not go to class. Okay. We have to get this thing though. I don't know how. We have to. Okay. Let's do another equation. How will we get that one? You guys that are sleeping should wake up. Okay, let's do this one that you did in class. Let's see. 1 plus x squared y double prime minus 4x y prime plus 6y equals to 0. And the first thing we have to notice is that our general solution is always written in terms of summation n equals to 0 to infinity cn x to the power of n. You can wake up and we can start writing, please. Wake that guy up. Then y prime here should give you, so by shifting this one, so I have n is equals to 1 to infinity. This will give me what? N cn x to the power of what? N minus 1. Then the other one here, y prime prime, here will give me n equals to 2 infinity n minus 1 cn x n minus what? Minus 2. Are we together? Then, so let's substitute. Let's start the first one here. 1 plus x squared y double prime. What will this one give me? That was y double prime plus what? X squared y prime prime, right? Abi now? Then what is this answer here? As summation n equals to 2 infinity n open bracket n minus 1 cn x n minus 2. Then plus I have x squared. I will follow in, please. Then x squared here I have n equals to 2 infinity. Then I have this one to give me, what is y squared here? n minus 1 cn x n minus what? Minus 2. Then by expanding this, you can have summation n equals to 2 infinity n minus 1 cn x n minus 2 plus this x squared will affect this one here to give you this infinity x equals to 2 to infinity here. Then what do I have here? n minus 1 cn. Okay, I can keep this answer. Then the next answer here is what? 4x y prime. I have 4x summation of, what is my y prime here? Infinity n equals to 1 n cn x n minus 1. Then this is 1 here, so this one will affect this one here to give me what? 4 infinity n equals to 1, which is what? Infinity n cn x to the power of what? X to the power of n. Are we together? So I think I can keep this one again. So since I've gotten everything, so let me now substitute. Everything that I had here was this one. This one is same thing as infinity, as our summation n equals to 2 to infinity n open bracket n minus 1. Are we together? Then here you have Cn xn minus 2 plus the next one here, summation n equals to 2 to infinity. Then this is n minus 1 Cn. Then from this Cn, where is x to the power 1? This I've forgotten here. This one here, minus 2. This one, okay, this one will be x to the power n, sorry. Then this will be x to the power n. Then, it should be minus now. I think it should be minus everything I have in this part here. Minus 4, open bracket, summation, n equals to 1, infinity, then ncn, x to the power of what? N, altogether. Then, plus what? 6, summation, what is that? N equals to what? 0 to infinity. This is what? Cn x to the power of n equals to what? 0. So I think I've expanded everything now. Let's try to make everything come to the power of. Let's try to make everything. So the summation must start at the same place, and at the same time too. The power of my x2 must be equal. So the only thing that is not making this one equal here is because this one is x equals to n minus 2. Then from here I can say that probably let's substitute that let m here is equals to n minus 2. And if n here is equals to n minus 2, then what do I have here? Or better still, because if n is equals to n minus 2 here, okay, let's go. Then I can now say that n here is equals to m plus 2. Abi now? Then n is equals to 2 means that m is equals to what? 0. Abi now? Then from here, why is it that it's only me that is active like this? I'm not getting this thing and you guys are sleeping. They don't see you. Now from this part here, so this part and this part here is equal. So I can just assume that. So from here, what will I have? N here is equals to what? M. And m here is equals to what? 2. When n equals to what? 2. That's not a big deal on this part. Also, is it not a big deal on this part, which is minus 4? Which is n is equals to what? M. And at the same time, what do I have here? N equals to 1, meaning m is equals to what? 1. Then the same thing here. On this summation here, and you have n equals to m, and m equals to 0 when n is equals to 0. Then if I put everything back inside whatever I have here, then this one can now give me summation. Instead of n equals to 2, when n equals to 2, I have m is equals to 0, then to infinity. Then what is my n here? My n here is what? M plus 2. Are we together? My n here is what? M plus 2 minus 1. Then what is my n here? Cm plus 2. Abi? Cm plus 2. Then what would this one give me? This one give me what? X to the power of. This will give me x to the power of what? M plus 2 minus 2. Yes or no? Then moving on to the next one here. Infinity. So I have n equals to what? 2 to infinity. Are we together? So this one now, it should be m equals to 2. Then what is my n here? That will be what? M open bracket, m minus 1, cm x to the power of what? M. And this one here, minus 4. If summation m is equals to 1, infinity m cm x to the power of what? M. Are we together? Then plus here 6, summation m equals to 0, cm x to the power of m equals to 0. So I think from everything I have here, the only thing that I don't have here is that I don't have 0. So let's work on this one here. I can have infinity m equals to 0. Then I have m plus 2, m plus 1, cm plus 2, x to the power of m, plus summation m equals to 2 infinity m, this will be m now, m minus 1, cm x to the power of m, then minus 4 summation here, m equals to 1 infinity mcm x to the power of m, plus 6 submission m equals to 0 infinity cm x to the power of m equals to what? 0. So I think I've gotten a way to make all my x start from the same point now. The next thing I have to do is what? Try to find a way to make all my my summation start from the same point. So the only thing I have to do is what? I'll move this one twice, I'll move this one once, and I'll move this one what? I'll move this one twice. So moving that one twice. So if I move this one twice, what will I have? So by first movement here, that will be at m equals to 0. So what will I have here? I'll have 2 multiplied by 1 c2 x. What will I have here? X naught. Then plus at the next point, which is 1, that will be 3 multiplied by 2 c3 x raised to the power 1. Then plus the next thing that we'll have here is summation m is equals to 2 to infinity m plus 2 m plus 1 cm plus 2 x to the power of m, plus the next one here infinity m is equals to 2, and I have m open bracket m minus 1 cm x to the power of m. Yeah, my question. Writing. Writing. You have to understand this thing, no? Then what do I have here? Minus 4. So if I shift this one by 1 term, what do I have here? C1 x1, I be now, plus summation m is equals to 2 to infinity mcm x to the power of m. Then the next one that I will have here is plus 6 open brackets. If I put m equals to 0 here, what do I have? C0 x0 plus what? C1 x1 plus what? Summation of m equals to 2 to infinity of cm xm equals to what? 0. Then from here, if you expand this one here, this will give you 2c2 x0 is gone. Then plus what do I have here? 6c3 x. Are we together? Then plus, let's move on to the next term here. Shouldn't be plus here. What's the next term here? Minus 4c1 x. Are we together? So minus 4c1 x. And for minus 4c1 x, next one I'll have here is what? Plus what? 6c0 plus 6c1 x. I think I've gotten these two. Then let me write all the summations back. Plus summation of what? M equals to 2 infinity. So m plus 2, m plus 1, cm plus 2, x to the power of m, plus the next one here, which is summation m equals to 2 infinity m minus 1 cm x to the power of m. Are we following, please? Are we sure? Hi, where are we lost? Where are we lost? So yeah, where are we lost? This point, what I did here, I just shifted this term. I shifted it. This one is 0, this one is 2, this is 1, this is 0. And I told you that for us to do this one, I must have the same starting point, and my x power, the power of x2 must be what? Must be the same. So that's what I'm trying to do here. Now for me, if I shift this point, the first point I will shift is by imputing 0 inside this formula. So 0 plus 2 is what? 2, multiplied by 0 plus 1 is what? 1. 0 plus 2 here is c2, x is power what? 0. Then plus, shift this one again. After 0, what is the next time after 0? 1. If I put 1 here, 1 plus 2 is what? 3. Multiplied by 1 plus 1 here is what? 2. Put 1 in this formula, you have c3, then you have x is power 1. So what this point here, I just shifted this one twice. This one here, I shifted it how many times? Once. This one here, I shifted it how many times? Twice. Whatever I'm just doing here, I'm just trying to collate everything that I have. Are you getting it? So from here, so the next thing I just did here was, I had 2c2, was I know the x0 will leave, plus 3 times 2 is what? 6c3x. Then the next one here is what? Minus 4c1x. Then plus this one here, 6c0 plus 6c1 x, and I think that's all. Then now rewrite all your summations back. So writing all your summations back, where am I? Okay, this one I'm xm. Then don't forget, use this minus 4. So I have minus 4 summation m equals to what? 2 infinity, and I have here to be mcm x to the power of what? M. Are we together? Then plus last one, 6 summation m equals to 2 infinity cm x to the power of m equals to what? 0. Then moving to the other side, and let me say I want to collate. Moving to this side here. Moving to this other side here. Let's say I want to move to this other side. So I want to collate everything I have here. So I can now say that. So I have 2c2 plus 6c3x all together. Then minus, what's the next one there? So I have minus 4c1x plus 6c1x to give me what? Plus 2c1x. Are we together, please? Are we together, please? Are we getting it? So I have added this one and I've added this one together. So 6c3x. So what's the next one here? Plus what? 6c0. Are we getting it? Then next one here, plus what is common everything here. So you can write out your summation m equals to 2 to infinity. Open your bracket. What inside this bracket is? So I have m plus 2, m plus 1, cm plus 2. Then the next one here, plus m minus 1. Then this is what? Cm. Then minus 4 mcm. Then what? 6cm. And everything is still multiplying what? X to the power of what? M equals to 0. So by comparing coefficient of x now, by comparing, so I can say that 2c2 plus 6c0 is equals to 0. That's my first comparison. I can compare that I have this. Then the second comparison I can have, if I want to compare x now, so if I want to compare x, I can say that 6c3 plus 2c1 is equals to what? 0. Don't what? I'm comparing coefficient with this 0 that is here. Then plus everything comparing to 0 will leave. So I'll be left with what? I'll be left with m plus 2, m plus 1, cm plus 2 plus m open bracket m minus 1 cm minus 4m cm plus what? 6cm. Everything is equals to what? 0. Then from here I can say that 2c2 is equals to what? Minus 6c0. And I can say that c2 is equals to what? Minus 3c0. I can save this. Then moving to the other side, I can have 6c3 equals to what? Minus 2c1. Abi now. And 6 and c3 is equals to what? Minus 1 over 3 c1. Then from here, make your highest term here the subject of the formula. What's your highest term here? Cm plus 2. So if I make this one the highest number of the formula, take everything I have here to the other side. So you can have what? M plus 2. Then this one give me Cm plus 2 equal to, let's take everything here to the other side. So I will have 4m Cm. Are we together? Then minus 6 Cm. Then minus m open bracket m minus 1 Cm. Are we together? Then so from here, what is common here? Cm. I can say that Cm plus 2 equals to Cm open bracket 4m minus 6 minus m minus 1 divided by m plus 2 m plus 1. Are we getting it, please? Huh? Are we getting it, please? I think this one here and this one here can be broken down, and at the end of the day, if I expand this is also the same thing as Cm open bracket. You know that I have 4m here. Then so if this m open this bracket, it gives me what? plus m. So this 4m plus this m will give me what? 5m altogether minus 6 minus what? M squared divided by what? M plus 2 m plus 1 altogether. So now that means I've gotten this. So from here I can now call this my recurring formula. So bring this formula out, so you can say that Cm plus 2 equals to Cm, open bracket, what do I have? 5m minus 6 minus m squared divided by, what do I have? M plus 2 and what? M plus 1. So you can now start. This is where the work starts. When m is equals to 0, what do I have here? I have C0 plus 2. Happy now? Which is equals to what? C0. Then everything I have here will be 5 open bracket 0 all together. Then what do I have here? Minus 6 minus 0 squared. And everything I should give me what? M plus 2. And this is what? M plus. So it's now M now. 0 plus 2. 0 plus what? 1. And at the end of the day, so I have C2 here. I hope you know that if I work on everything here, I will have what? Minus 3 C naught. Let's now do. So I've done when m equals to 0. The next one is what? When m is equal to 1. When m equals to what? 1. So what will I have here? I will have C3. But don't forget that C3 automatically give me what? Minus 1 over 3 C1. I will get that. And the next time will be that when m is equals to what? 2. If m is equals to 2, what will I have here? I will have C4, which will give me, so I have here to go C2. If I put inside this formula, what would I have? C5, and that will give me what? Equals to what? C3 all together. And open bracket, what do I have here? 5 times 3 is what? 15 minus 6 minus what? Minus 9. Have you now? Why is everything giving me 0? Okay. Let's see. The next one is going to give me 0. Then everything here is what? I have 2 to give. 3 plus 2 and this is what? 3 plus 1. So because of whatever I have here, C5 automatically will give me what? 0. Let's look at it so that we can get it. Next one here, let's look at it. Okay, look at it. Whatever I'm having is 0, 0, 0, 0, 0.
Everything that we got in 10 classes. I think after C1, C2, after C2, C3, the rest are 0.
Yeah, that was it.
I think that's what we got.
Oh, good. And C4 is 0. Everything goes 0. Now this is, I think I've gotten to the resting place I can get to. So please let me now make it, because I love, don't worry, when next you have an interesting one, we'll do more exercise on it. Like I know you have it today, like when next you have it today, we do more exercise on it. So now this is the thing that we have here, so that you can make a perfect plan on how it looks like. Whenever you have the differential equations like this that they ask you to solve. So please listen. Let me give you and int. I've gotten it from here. We continue. I don't know that this one will be 0. We don't that shit here. And this is what you first do. The first thing that you have to do is that you first of all differentiate it in this order. Have you got one apprentice like that? And after you have differentiated it in this order, then you now start to what? Substitute whatever I have here. So by substituting whatever you have here, then you will end up having some equation in terms of what? Summation. Now the first thing you have to do is that try as much as possible to make the power of x the same thing first. I get to my apprentice like that. So if the power of x is the same thing, then you can now move on to make your summation to equal. I get my apprentice like that. But first thing I have to do first is that try as much as possible to what? Make the power of x equal here. I think that is what I did from where is it? From this point here. The power of x here was xm, 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 xm. That was why it was easy for me to what? To move. The other ones that we were doing, I think the ones I did before was I had to make the exponential. I had to make this one equal first before the x. That's why I had problem. So next time you want to do it, let us create the plan. The first thing you have to do is what? You start by making the power of your x equal. And after the power of your x is equal, the next thing will be equal to what? You now shift. You now shift. And when you are done shifting, then if you are done with whatever you are shifting now, you can now start by collecting the like terms together. And you can now compare as you have here. I get my friends like that. So from here you can compare in the sense that you pick everything that does not have x first. You compare them to 0. And the next one you pick again, you pick the one that has what x, what? Compare them to what? 0. Then you pick this your final one and compare them to 0. So it is the any equation that you have on this term. Listen, no, it is any recurrence equation that you have on this term that you work with to start generating your term. You want someone apparently like that. So you can write this one here. I don't know if it will give you 0, 0, 0, 0, 0, 0. That's not the answer, but I can write the answer now. I can write the answer now. But before I want to write everything that I have written here in this part here. Writing everything I have written to this part. Don't worry. Next time today, we'll deal with this one more. Probably 3 examples. Although it will be long, but we'll do it. Do you understand what I'm writing like that? Please do it get. So I want to clean this. I want to clean this next part. So that next part will be where I will now generalize whatever I'm doing. I want to clean the next part.
So which will be where I will generalize my final answer. So have you gotten to this part? Like I want to clean that part. Alright, let's write fast then. Let's write very fast so that I can move on to that part. So from there I can now compute my own answers. I don't know that this. It's a pity. But please do understand. So what is the first step? Don't forget. The first step is what? You let your general solution be like this. Then after your differential, your general solution is like this. Then you now start what? Differentiating. Yes, you can. They can. But basically, the only thing that we are dealing with here is only what?
By differentiating, your summation is moving by what? By 1 point. Then after you get here, then after I've gotten to this part here, you now look back to your question and make your necessary what? Substitution. Do you understand what I'm trying to say like that? Then after I bring your necessary substitution, you have something that looks as weird looking as this. Then from what you have here, start by making what solve your formula first. Make the power of your x equal first. How do you make the power of your x equal? You can just do this minus substitution that I've done here. I see it. Do that minus substitution to make the power of your x proceed to make your what? Your summation start from the same origin. That this one started from 0, this one is what? 2, this one is what? 1, this one is 0. So most of the time, you have to try to make everything start from what? Start from 2. So that's why I move. And for you to make them start from 2, you have to what? You have to move the recurrence formula. How do you move it? You put your 0 inside, you have an answer. You put your 1 inside, you have also an answer. Then you can continue to like that. Then if you have done all this and you have moved, then the next step that you come here will now be that you now start collecting both terms, collecting like terms together here. How together, please? Okay. Although what you have on the board here might seem as if it is very, very long. Long in the sense that there's also, I will tell you that you should expect, I'll tell you that you should expect questions like this. I saw one of these questions then and I did it because I knew it then. It was very easy for me to compute. You understand what I'm trying to say like that? So please, let's get prepared that next time we'll be meeting, which will be today. I don't know when today we'll be meeting. Or you don't need to forget about that. Next time we'll be meeting today. We'll be what? We'll be solving more questions. Do you understand? And I leave set of human beings. They are sleeping. And I remember the first time I learned this thing, I did 3 questions all night and I did not even get to 1 when I was learning this. It was the same mistake I was making here that was making them. And I had to cancel. But now that I've gotten it now, I've gotten it back. I'll get on my brain say like that. So please, let's take note. Let's take note of it. Yeah, I will have concluded this answer. But I can't conclude this answer because you guys are still right. So now, to conclude this answer now, I can just say that my general solution here, if you can remember, my general solution is in terms of what? In terms of y equals to, what do I have there? Summation. Sorry, it's not the same thing. N equals to 0 to infinity of c and xn. Then by the time I compute this answer here, then what will I have? If you start expanding it, you should give you what? C naught x naught plus c1 x1 plus what? c2 x2. Then as you can continue, as long as you can get to, plus ... I think everything else I have apart from, okay, I think I have c3. Then c3 will give me what? x3. Then apart from c3, everything else I have was what? Was 0. So I can put plus ... Then what is your c naught? Your c naught is what? You're still c naught. X raised power, that one will leave. What is your c1? You see what? Still c1x. But what is your c2? Your c2 is what? Minus 3 c naught. Are we seeing it like that? Then plus what is your c3 here? Minus 1 over 3 c1 x cubed. This one is x squared. I'll get what I'm trying to say. Then from here, you can collect like terms together and say that you have c naught minus 3 c naught x squared. Then the next one is what? Plus c1 minus 1 over 3 c1 x raised power what? X raised power 3. Then you can have plus . And that will be the end of the class for today. So now moving on to the next class. I will say that. So let's finish writing so that we can move on to the next class. So that will be my final answer. But don't worry, next time that we'll meet today, this is our final answer here. So next time that we'll meet today, we'll meet and we'll move on to what? We'll move on to more examples on that. So the next course that we'll be doing, comparing, yes. Yeah, from comparing, move on, write all of this straight down. This is one part, another part, then another part. Then from this part, after I've written this part here, then you now move on down here. You now start when m equals to 0, when m equals to 1, when m equals to 2, and all of these names. What are you going to do? So now, next one is MTS 201. So the last place we start from our MTS 201, we started from integration. So let's continue from integration. So continuing from integration, here, I think the first class we did on integration then was our general integral, which was this first form. We have a to the power of, x to the power of n dx, and this is the same thing as saying the integration of, or this will give you s to the power of n plus 1 divided by n plus 1 plus what? Plus c. And also if you add x to the power of, not x now, a to the power of x's power n dx, which is equal to ax n plus 1 n plus 1 plus c. I think this was where we stopped our last example for those of us that came in the afternoon. So let's continue our journey from here. Now the second type of integration I will be looking at, let's look at algebraic substitution. So let me call that one algebraic substitution. So for algebraic substitution, although it has two forms, algebraic substitution has the first form. Now this is the first form of algebraic substitution, probably if you are integrating something that has to do with 4 minus 3x raised to power. Let's write now, if you are here. Let's write 4 minus 3x raised to power what? Raised to power 5 dx. Then we want to integrate this. Then if we say we want to integrate this one, so now how do we do it? Now first thing that we can do here is that I can try to write everything here as a single function of x. So I can say that let u is equals to 4 minus 3x. Then if I differentiate both sides, the u here will give me minus 3 dx. Then making dx subject of the formula here, I can have dx equals to what? Minus du over what? Over 3. So substituting all of those back inside this place. And here I will have u raised to power what? 5 multiplied by, what is my dx here? Minus du over what? Over 3. Then bring this one out here. I have minus 1 over 3 u raised to power 5. Or better still, let me write it in this form. Write it as u raised to power 5 multiplied by minus 1 over 3 multiplied by your du. Then, in this case, what I will have here will now be minus 1 over 3 integral of what? U raised to power 5 dot what? Dot du. Then from this, our first law of integration, I can say that I have minus 1 over 3. If I integrate u raised to power 5, what will I have? U raised to power 6 over 6 plus what? Plus c. And your final answer will give what? Minus u raised to power what? Minus u raised to power what? 6 over what? 18 plus c. But don't forget that here, whatever you did here was just what? Algebraic substitution. So if you do that substitution back, don't forget you use what? 4 minus 3x. And from here you can have minus 4 minus 3x raised to power what? 6 divided by what? 18 plus what? Plus c. Do you understand? So that will be my what? My final answer. So this is just algebraic substitution 1. So there are a lot of things I can apply to this one here. Okay, I can also apply this example 1 I can also apply another example to this, probably exponential 2x minus 9 dx. Now I want to differentiate. I want to work on this too. So working on this one too here, I can say that I can make everything I have here u, which will give me what? 2x minus 9. Then by differentiating this, the u will give me what? Will give me 2 dx. And I can say that my dx is equals to what? Du over what? 2. Put all of this formula back here, then I'll have integration of what? Exponential. What do I have here? U multiplied by, what is my dx here? Du over 2, which is the same thing as integration of exponential u multiplied by 1 over 2 du. Then take 1 over 2 outside. I can have 1 over 2 integration of what? U du. And according to the table I gave earlier on, if you integrate exponential u, your answer is what? Exponential u plus what? Plus c. And this time around, don't forget 1 over 2. What was the value of your u? Exponential what? 2x minus 9 plus what? Plus c. That was what that will give us about that. Are we together? Although this one has its own form of shortcut. That's its own shortcut. So let me continue. I want to clean this part. I think we've dealt with this part. Now another part that we can look at here. Let's look at the third one. And the third part, which is let's integrate sine 2x minus 8. Sine 2x minus 8 dx. Then from this case, then I can make everything inside this my bracket equal to what? U. Like I said that my u is equal to what? 2x minus 8. And my du is equals to what? 2 dx. That is, if I differentiate du, I will only differentiate 2 here. Then for me, if I make dx sub to the formula, I will have du over what? Du over 2. Then by making du over 2, substituting that back here, I have integration of what? Sine. What will I have here? Everything here is what? Everything here is u multiplied by, what is dx here? Du over what? 2. Then multiplying or breaking this one down, you can have sine u multiplied by half multiplied by what? Du. And your half, which is a constant, can come outside of integration sign. Half sine u dot what? Du. Are we together? Then so from here I have 1 over 2. If we integrate sine u, you have what? Minus cos u plus what? C. Now at the end of the day I have what? Minus cos u over 2 plus what? Plus c. And what is your u here? Your u here is what? Minus cos. What is your u? Your u is what? 2x minus what? 8 divided by 2 plus what? Plus c. That will be my final answer. So these are just the basic simple tricks we can have on. On integration. So let's move on to still on algebraic substitution 2. But I want to continue, want to move higher. Okay. Then from here, so if I continue from this part, okay, let's just make a very simple trick to this one. Whenever you are differentiating, it's a very, very simple trick. Now, whenever you have something that looks like this format, okay, let's continue. Before I come back to that, let's look at algebraic substitution 2. Algebraic substitution 2. So in algebraic substitution 2, now this time around, will be based on these kinds of question. Probably 2x exponential x squared minus 4 dx, number 1. Number 2, we'll be dealing with integration of probably 2x minus 5 Then here I have x squared plus 5x minus 5x plus 7 raised power 21 dx. Then number 3, if you want to integrate ln x over x dx. Number 4, if you want to integrate sine squared x cos x dx. I want to integrate something that looks like this. Now, how do we deal with integration like this? X squared minus 4 dx. How do we do that? So with this side, one thing I want to do is that this equation will be written in such a way that to be able to differentiate one to get the other. That will be the first part that we have to know, that this differential equation was written in such a way that to be able to differentiate one of those functions to give it the other. And I think the first one that I can do here, I cannot differentiate x squared to give me whatever I have on this part, but I can differentiate what I have on top to give me what? 2x. I can say that let u equals to what? X squared minus what? Minus 4. Then the u here is equal to what? 2x dx. Then from here, if you differentiate this, I mean, divide both sides by 2x, I can say that the x is equal to what? The u over what? 2x. Then from here, so I have integral of what? 2x. Now exponential. Therefore, you write x squared minus 4, like exponential u multiplying what will be x here? The u over what? 2x. 2x can cancel 2x to give you what? Exponential u dot what? The u. Are we together? And if we integrate exponential u, what do I have? Exponential u plus what? Plus c. And at the end of the day, if I integrate this, what do I have? I have exponential. What is my u now? My u is what? X squared minus 4 plus what? Plus c as my final answer. Are we together?
Let's look at number 2. As I said, how do you recognize number 2? Number 2, as the same way I did in my number 1, is that the equation is in such a way that you be able to differentiate one of these functions to get you the other function. I will get one approach like that. You'll be able to write it in such a way that either of those functions will be able to differentiate to give you the second function. Now, so from here, from the way it looks like, so there's no way I can differentiate what I have here. I mean, there's no way I can differentiate what I have here to give me this one here. But I know that if I differentiate this one here, I will have this one that I have here. Are we together? And so from here, I can say that let u is equals to what? X squared minus what? 5x plus 7. Then du on this case will give me what? 2x minus what? 5 dx. Then from here, I can say that dx is equals to what? Du over 2x minus 5. Are we together? Then so from here, let's substitute back inside this place. Then substituting back inside this place, I will have 2x minus 5. Now, everything here has been represented as what? I've represented as u raised by what? 21 multiplied by what's my dx here? Du over 2x minus 5. Then from here, let this one and this one cancel out. Then I'll be left with integration of what? U raised power 21 multiplied by what? Du. And at the end of this day, everything here should give me integration of u raised by what? 22 over 22 plus what? Plus c. Do you get? But I cannot leave answer here in terms of u. I have to substitute back. If I substitute my u here, where's my u? My u is what? X squared minus 5x plus 7. Everything is power what? 22 divided by 22 plus what? C. Let's write this fast.
So I want us to write this very, very fast because we have a very long way that we are going. So this is how the second one will look like. And let's take a look at the third one, which will be integration of what? Ln x over x dx. I don't want it to look as if I'm rushing you guys, but let's increase the pace. Then so from here, ln x over x dx. Now, as I said that algebraic substitution should be written in such a way that either x, either of those equations here will be what? Differentiable. Yes or no? So that means there's no how I can differentiate x to get ln x. But there's a slight tendency for me to what? Be able to differentiate ln x to get what? X. Yes or no? So for me, I can say that u is equals to what? Ln x. Then by differentiating it, I have d is equals to what? 1 over x dx. Then from here, what will I have? I will have, by cross multiplication, I will have x du is equals to what? Dx. Are we together? Then so from here, I can now substitute everything I have back inside this place. So what will I have? I will have integral. What is my ln x? U over x multiplied by what is dx here? X du. If this one cancel out, then the whole answer here we have integration of u du. And if you integrate u du, what do you have? U squared divided by 2 plus what? Plus c. And the final answer here should give you what? Don't forget, what is your u? Ln x. Then everything squared divided by 2 plus what? C. So this will give me my what? My final answer. Are we getting it? So how do you recognize these ones? I told you, they will be written in such a way that it should be easy for you to separate. It should be easy for you to differentiate one to give you what? The second one. Are we together? So, to this part here, so from this part here, so let's look at number 4. So looking at number 4, so what do we have in number 4? Number 4 is written as the integration of sine squared x cos x dx. Yes or no? Now this one here, as I said, it should be easy for me to write one in order for me to differentiate the other. I hope you know that it is, although this time around, I can either write u to be sine x, because I'll be able to use to differentiate cos x, and I can also I can write x to be cos x, which can also be written as what? As sine x. Are we now? So from here, I can now have, let me just assume that let u is equals to what? Sine x. So if u equals to sine x here, then what do I have? Du equals to what? Cos x dx. Are we together? Then from here, then I can say that I have substituted everything back inside this place. And I have dx is equals to what? Du over what? Cos x. Putting everything back here, I now have integration of what? U squared multiplying what? Cos x. And what's your dx here? Du over what? Cos x. Then everything here cancel out. Then you have integration of what? U squared du which will give me what? If you integrate this you have u cube over 3 plus what? Plus c. But don't forget what your u is sine. So you have sine x all cube over 3 plus c, and which is the same thing as saying sine cube x over 3 plus what? Plus c. That will be my final answer. Do we get? So, I don't know, this trick number 3 is written in this form as if you have integration of f prime of x over f of x, you will dx. The answer is ln of f of x plus c. That's the differentiation that we have next. So if you want to differentiate that, so I have that. So now what does this one mean? It means that if you have a differential in which, if you have an integral in which once you differentiate the denominator, differentiate the denominator, you have your denominator, in which once you differentiate your denominator, you get your what? Numerator. So any scenario like that will give you what? ln of your what? Denominator. So let's look at examples like this. So examples. So I want to integrate x squared plus 7, minus 7x plus 8 dx. That's number 1. Number 2, I want to integrate exponential x. Oh, don't let me go there yet. I want to integrate tan x. I want to integrate tan x dx. Number 3, you want to integrate cot x dx. Number 4, you want to integrate two x squared plus 4, 2x squared, or let me call it 4x plus 4 divided by x squared plus 2x minus 7 dx. Number 5. Then by number 5, you can have something like this to be 2x minus 3. Here should now give me 2x squared minus 6x plus 15 dx. So I want to integrate all of these 5 integration questions. Integrate all of these 5 integration questions. All of this integration is very simple, but the main thing is that you must be able to to find out which one you differentiate. That will make you get your your numerator. I'll get in it. Now from the first part here, let's look at it critically. So from the first part, what do I have? So if I differentiate x squared minus 7x plus 8, what will I have? You find out that I have what? 2x minus 7. So because of that scenario, I can now have answer of number 1 to be ln of what? x squared minus 7x plus 8 dx. Not dx here. Plus what? Plus c. Number 2. Now I want to integrate tan x. So according to definition, tan x is what? Sin x over what? Cos x dx. But this time around, if you differentiate cos x, you are not supposed to get what? Ordinary sin x, you're supposed to get what? Minus sin x. So if I'm supposed to get minus sin x, that minus I don't have here, I will include it outside. Then it should give me what? ln of what? Cos x. And number 3, want to integrate cot x, and cot x is 1 over tan x dx, which is the same thing as saying cos x over what? Sin x dx. And if you deal with this, your answer here will be what? ln of what? Sin x plus what? C plus c. always want to branch like that. Then from here to number 4. So now let's look at number 4. So by integrating here, what do I have? We find out that I have. So now this time around, let's look at it critically. Find out that if I differentiate the denominator, I will not have the numerator like per se. I will get one branch like that. I will not have the denominator per se. But here, let's do something. So let me have 4x squared plus 4. Now from here, if you differentiate this down here, what will we have? You have 2x plus what? Plus 2. Right? So you can see that the only difference that this one have, that this one does not have, is what? 2. I'll give you 2x plus what? 2. Divided by what? 2x plus 2. This is the shortcut method. Now this 2 that is making it different, you write it out as a what? Answer. Then you now have your limit. If you differentiate, what do we have down here? Which is what? You now have x squared plus 2x minus 7 plus what? Plus c. Do you understand? And number 5. Now you have 2x minus 3. Now this time around, so let's do the differentiation here. So do the differentiation here. Now if you differentiate everything here, what do I have here? I have 4x minus what? Minus 6. Yes or no? And from this part here, if you can know, you find out if I factorize 1 here, 2x minus 3. And if I factorize 2 here, what do I have here? 2x minus 3. So what makes the integration different? The only thing that makes the integration different is what? 1 over 2. So your answer will have what? 1 over 2 ln of what? 2x squared minus 6x plus what? 15 plus what? Your arbitrary constant c. Do you understand? You understand? Okay, that will be that about that for this section. Now for the next section, now we'll be looking at integration by partial fraction. Integration by partial fraction. So now, as next thing want to deal with now. So want to start integrating by partial fraction. Now, to integrate by partial fractions, there are some forms of partial fractions that we have to understand first. There are some forms either. Now, the thing is that the first form of partial fraction you have to understand is that whenever you have, okay, how do I write it? Okay, let's do it as an example. Now let's say that here you have number 1. Let's say you want to integrate 2x minus 9 over x squared minus 4 dx. Here, like the ones we did, there's no way that I can differentiate my denominator to give me what? Numerator. Yes or no? But everything I have down here can be split into 2. So if I split everything down there, what do I have? I can now have, which is equals to the equation of 2x minus 9 over, now this is x squared minus 4. So x squared minus 4 is the same thing as dealing with what? Difference of 2 square. That is x plus 2, x minus 2. Are we together? Dx. Then from here, so another thing that you do is that for you to integrate by partial fraction, you isolate your partial fraction here. So let's isolate this partial fraction here. So by isolating this partial fraction that we have here, I think you have 2x minus 9 equals to what? X plus 2, x minus 2, all together, which is equivalent to this type now. Now, whenever you have whatever type of function, but as far as the denominator is a repeated linear function, you can write it the format as a over any of those functions plus b equals to what? X plus what? X plus 2. Yes or no? Now this is what it means to be equivalent. You can have 2x minus 9 equals to a open bracket x plus 2 plus what? B open bracket x minus 2. So here, instead for you to stress yourself by expanding it, you will not expand. So by expanding this one, you don't have to expand. You can say that let x is equals to what? Let x equals to 2. Then by letting x here equals to 2, I have here to be 2 is power 2 minus 9 equals to a open bracket 2 plus 2. Then from here I have 4 minus 9 equals to what? 4a. And my a here is equals to minus 5 over 4. I've gotten my a, which is minus 5 over 4. So I've gotten to minus 5 over 4. Then after that, our next one is let x here, I choose x to be equals to what? 2. Now let's put x to be what? Minus 2. So to put x equals minus 2, what do I have? I have 2 open bracket minus 2 minus 9 equals to what? A open bracket minus 2 plus 2. Then plus b open bracket minus 2 minus 2. Then this is what going to give me minus 13 equals to, this will give me what? Minus 4b. And now b here is equals to what? 13 over what? 13 over 4. Do we get? Now 13 over 4 is what you have. So now, so from here, you have gotten your a, and I have what? You have gotten your b. Are we together? I've gotten a and I've gotten b. So let's write this equation again. So 2x minus 9 over x plus 2 x minus 2 is equivalent to, now what do I have here? What is my a? My a is what? Minus 5 over 4. Yeah, multiplied by what? 1 over x minus 2. Then plus b is what? 13 over 4. Then I will now introduce you to solve any problems. And what is the problem? 1 over x plus what? Plus 2. Are we together? And so from here I can put this one here in terms of what? This integration. Are we getting it, please? So by putting that, I can say that integration of what? 2x minus 9 equals to what? X squared minus what? Minus 4 dx, which is equivalent to, now what will I have here? Minus 5 over 4 1 over x minus 2 dx. Are we together? So then what do I have here? Plus 13 over 4 open bracket 1 minus x plus 2 dx. So everything here, which is the answer to this equation here, and I give me minus 5 over 4 ln of x minus 2 plus 13 over 4 1 over x plus 2 do I, yeah, I've integrated. It will be ln of x plus 2. Then so from here, If you collect like terms together and you swap, you can have, let's leave my answer like this. So please, that whenever you have a repeated fraction and it's a linear fraction, what can you do? You can split it to what? To individual smaller fractions. Do you get what I'm trying to say like that? Okay, let's look at another example. Another example here, number 2. Let's say that this time around you want to integrate the equation of 4x divided by 2x squared minus x plus 1 dx. So let's have something like this. Now, one thing I want you to notice is that you notice that something like this here does not have, it's not repeated unlike this case here. Yes or no? Now, but this one, despite the fact that it's not repeated unlike the other case, what it means is that this one here can be factorized. Abi now, can it not? So let's factorize it. So by factorizing this part here, so let me bring this one here. You have what? 2x squared plus x minus 1. By factorizing this, I think you know that this one will give you what? 2x squared plus 2x minus x minus 1. Yes or no? And from here, first will be 2x divided by x plus 1 minus 1, the other area, x plus 1. I have 2x minus 1 by x plus 1, right? Are we together? Are we together? So from there, so from here, then I can now rewrite this equation back in terms of this, and I can have this to give me 4x divided by, say for me to have everything like this, what do I have? I have everything like this, which is written in form of what? 2x minus 1 over what? X plus 1. Are we together? Are we getting it? So this one here is what? Is the x. Then as I said, you can do what? You can confidently what? Isolate what is in what? What's in the middle? Yes or no? So let's isolate what is in the middle. So isolating what is in the middle, you have what? 4x equals to what? 2x minus 1 multiplying what? X plus 1. Yes or no? And I told you that whenever you have a repeated linear equation, or a linear equation most of the times might not be repeated, it can be written in this format, which is what? A open bracket what? 2x minus 1 plus what? B open bracket what? X plus 1. I'll get one apprentice like that. Then from here, you can say that everything here, okay, let me move on to this part here. Then you can say that everything here, 4x divided by 2x minus 1, then not x now, then x plus 1 is equivalent to A open bracket what? X plus 1 plus B open bracket 2x minus 1. Everything divided by 2x minus 1, and everything is what? X plus 1. Then so from here, since the denominator are equal, then I can include the numerator, which is what? 4x equals to what? A open bracket x plus 1, then plus b open bracket 2x minus 1. How is it? Then so from here, 1. So then from here, I can now be like, continue. Let me say I want to, let's say, let x equals to what? Let x equals to not 1 now, this time around, minus 1. So that I can substitute. So what do I have? I have 4 open brackets minus 1 equals to what? A open brackets minus 1 plus 1 plus b open brackets 2 open brackets minus 1 minus what? Minus 1. What do I have here? I have minus 4 equals to, everything will give me what? 0. Then I'll have plus b open bracket minus 2 minus 1 is what? Minus 3. Then if I divide both sides by minus 3, I can say that my b here is equals to what? 4 divided by what? By 3, right? Okay, good. I've gotten b. So now at the same time, I can choose any point of my discussion. So now I want to work with this. So I can say that let x, I eliminated a to get b. So let me eliminate b to get a. I can say that let x equals to what? 1 over 2. So putting 1 over 2 inside this question, what will I have? I have 4 open bracket 1 over 2 equals to, I have A open bracket 1 over 2 plus 1 plus B open bracket 2 times 1 over 2 minus 1. Are we together? Then 2 can cancel 4 to give me what? 2 equals to A open bracket here 3 over 2 plus B open bracket, everything here is 0, right? Let me leave this. So for me, I think the best way to do is what? Is to multiply everything by 2 and divide by 3. Abi now? So this one, my second answer that my A is equals to what? 4 over 3, which is the same thing as what I have as my what? As my B. Do you understand? Then from there, I can now move and write this. Then, okay, so since I have successfully broken this one down, then I can say that 4x, what is that? Okay, 4x divided by what? 2x. What is that? 2x minus 1. Then I have x plus 1 is equals to 4 over 3 multiplying, what do I have there? 1 over 2x minus 1 plus 4 over 3 multiplying 1 over what? X plus 1. So from here, I can now put this one, so I can say that therefore 4x over 2x minus 1, and this is x plus 1 dx equals to 4 over 3, or let me put the integration of open bracket 1 over 2x minus 1, then plus 4 over 3, 1 over what? X plus 1 dx. Are we together? And so from here, I can split this to give me 4 over 3 integration of 1 over 2x minus 1 plus 4, no, let's do it like this, dx, then plus integral of what? 4 over 3, so 4 over 3 will be outside, 4 over 3, then I have what? 1 over what? 1 dx. So from here you have 4 over 3. If you differentiate what I have here, I think it's supposed to have multiplied by what? 2 ln 2x minus 1. Do you know why it's 2 ln? Because if you differentiate, yeah, it's supposed to be 2. So that 2 that is not there, you put it. Is it 2? Is it 2 or 1 over 2? It should be 1 over 2. Yeah, it should be 1 over 2. Plus 4 over 3. Then if I integrate this, I have ln x plus 1 plus c. Then from here, 2 will cancel 4 to give me 2 over 3 ln of 2x minus 1 plus 4 over 3 ln x plus 1, then plus c, arbitrary constant. Do we get that, please? Do we get that? I'll put this on inside bracket. So now, the next one here is this. We have done repeated base, right? Okay, let's have another caliber of partial fraction. Another caliber of partial fractions. Are we together? Are we writing? Let's write now. Let's write. So another caliber of so let's look at this type of differential equation. Let's say you have want to integrate 4x over 4x minus 1 over 2x minus 9 everything is power 7 dx. Yeah. Then let me use 7 now. 7 is too big. Let me use 3. I have something like this. I want to solve it in partial fractions. The first thing I have to do is that isolate what is in the middle first, which is what? 4x minus 1 divided by what? 2x minus 9. Everything here is what? With power 3. Are we together? And so for me, I have 4x minus 1 over this one here can now be 2x minus 9 plus 4x. No, it shouldn't be 4x, now it should be a, then plus b over 2x minus 9 squared plus c over what? 2x minus 9, everything is about what? 3. Are we together? Then from here, I can have 4x minus 1 over what? 2x minus 9, everything here is just about what? 3. Then what is the LCM of everything here? 2x minus 9 is about what? 3. Then this one is here. Are we together? Then what do I have? I have a open bracket 2x minus 9 all squared plus b here. What do I have here? 2x minus 9 plus c. I have nothing left. Are we together? So for me, I can now compare and contrast and find out that I have 4x minus 1 equals to 2x minus 9 squared plus b is looking at 2x minus 9 plus what? Plus c. So I think here the best way to resolve whatever that is resolvable here is by opening the bracket. Then if I open the bracket here, although it might look a little bit long and messy, so if I open the bracket here, what do I have? A open bracket 4x squared minus what? 18x, not 18 now, it should even be 36 minus 81 plus 81 plus, open this will give what? 2bx minus 9b plus c. And from here, you can have a, but that's still fetch a x squared minus 36ax b. Abi now plus it's 1a, then plus 2bx minus 9b plus c. Let's collect like terms together. So by collecting like terms together, what do I have? I have 4ax squared and minus 36 plus, okay, I think nothing, they are different, plus 2bx minus 36ax plus 81a minus 9b plus c. By comparing and contrasting, I can say that, forget this is what? X minus 1, so I can say that a here, which is s squared, does not have anything here, which will give me what? 0. Plus, so here, b, so which still have something here. So if I want to compare now, what do I have? I have 4 equals to what? 2b minus what? 36a. Yes or no? And so from here, since my a is 0, my b, so I can have 4 equals to what? 2b, and my b here is equals to what? 2. I've gotten a, I've gotten b. Are we together? The next one is for me to go and get c. How do I get c? This is your constant term, so which is 81a minus 9b plus c equals to what? 1. So from here, you have, okay, minus 1, thank you. Then everything here will give me 0 minus 9 open bracket 2 plus c equals to what? Minus 1. And this will give me what? Minus 18 plus c equals to what? Minus 1. Is equals to what? 17. I will get on a printed that. So I've gotten c, I've gotten a, I've gotten b. So the next thing I have to do is what? Is to substitute the back inside my general equation. Then next thing here, I've gotten A, I've gotten B, and I've gotten what? C. Let's put everything back in my normal equation. So I can say that 4x minus 1 raised to power what? 2x minus 9 everything to power 3 is equals to, what's your A? 0 over 2x minus 9 cube. I mean now, no, minus 9. Then what is B? Plus 2 over what? 2x minus 9 squared. I was get that. Then plus what? 17 over what? 2x minus what? 9 raised to power what? 3. Then so if I integrate both sides, by integrating 4x minus 1 over 2x minus 9 dx, so I'm all cube dx. So this will still the same thing as, I won't have 0 here, so I will have 2 over 2x minus 9 all squared dx plus integration of 17 over 2x minus 9 raised to power 3 dx. I will get that, please. So from here, I hope you know that this one here can be written in this format as integration of 2x minus 9 raised to power minus 2 dx. Then plus what? Integration of 17 open bracket 2x minus 9 raised to power what? Minus 3. I will get that. So from here, I can, yes, I know, but let's just take it step by step. So from here, bring your 2 outside. Bringing your 2 outside here, you have what? 2x minus 9 raised to power what? Minus 2 dx plus integration of, not integration of anything now, 17 integration of what? 2x minus 9 raised to power what? Minus 3. Now, if I want to apply shortcuts, whenever I have a linear function like this, you have 2. Now, whatever you have is that, first of all, write 1 over, differentiate what is inside your bracket, that will give you what? 2. Then write your question and add 1 to the power. That will give you what? 2x minus 9, subtracting 1 from the power, minus 3 over what? Minus 3. I will take that. Plus 2 times 7, okay, I think that's all. Then close bracket plus what? 17. Then repeating the same thing again. This is 1 over 2, 2x minus 9, everything. So this will give me minus, this one can give us minus, this will give me minus 1 now. Now, this one will give me what? Minus 2 over minus 2, right? Then so from here, so here I can have minus 1 over 2x minus 9. I will together minus, because minus 17 over 4 open bracket 2x minus 9 all squared. Do you understand? Huh? Okay, let's write that. So there are many forms of differential equations you can write. Many forms. Many forms of differential equation that you can write. Yes, thank you. Plus C. So now on partial fractions. Okay. So I've treated, repeated. Let's look at something that looks a little bit unusual. So once you integrate this, also want is also what? Partial fractions. Right? First thing first that we have to do is what? Isolate it. Now. Let's isolate it. So what do I have there? I have 2x minus 5, x minus 1, x plus what? X plus 9. And all things being equal, x squared plus 9 is a quadratic equation we cannot be what? Factorized. So what will be the form? The form here will be a over your linear plus what? Bx plus c, or what? S squared plus what? Plus 9. So here I can have 2x minus 5 equals to a open bracket x squared plus 9 plus b x plus c open bracket x minus 1. Are we together? Okay, let me leave it like this to make my work faster. Then from here, so I have 2x minus 5 equals to ax squared plus 9a plus bx squared, plus bx plus what? Cx, minus c. Bx times this. Okay, sorry. So this one here. Okay, yeah, this one is minus bx plus cx minus c. Okay. And from here, collect like terms together. So I have 2x minus 5 equals to, what do I have here? Ax squared plus what? Bx squared, all together, plus cx minus bx, all together. Then what is the next one here? Minus what? Plus 9a minus c. Yes? Happy now? And so from here, I can now say that comparing coefficients, that a plus b equals to 0. Next one, c minus b equals to what? 2. And next one, 9a equals to what? 9a minus c equals to what? Minus 5. And here, I can say that a here equals to what? Minus b, or better still, let me say that b is equal to what? Minus a. And putting that here, I have c minus a equals to 2. I'll give you c plus a equals to 2. Then if you write this one again, you can have a plus c is equal to what? 2. Yes or no? Then from here, if I add everything here together, everything here should give me what? Na, right? Then equals to, what does one give me? Minus 3. Have you now? Good. Then here you can have that a is equals to what? Minus 3 over what? Over 10. Are we together? Okay. So I've gotten a. So if I've gotten a, if I've gotten a, then my b will be easy. Have you now? Then put that one here, so I can have b to be what? Minus 3 over 10. And the answer here is going what? 3 over 10 as my b. Now let's now get to my c. Now how do I get to my c? C here will now give me, that will be c minus what? 3 over 10 equals to what? 2. Right? Then c is equals to, now 3 over 10 is the same as 20 over 10, so I can have 23 over 10 if I take this one to the other side. So now I've gotten c, I've gotten b, and I've gotten what? A. The next thing I have to do is what? Put everything back inside my what? My formula. Abi now? Okay, let me see, do that here. Please, I hope you are following me, please. Are you sure? Okay, good. So follow me, please. Don't leave me. So let's continue from here. Then, so let me put all of my variables back inside this place. So putting that variables back there, I have 2x minus 5 divided by x minus 1, x squared plus what? Plus 9. Then here, what do I have here? What is my a? My a is what? Minus 3 over 10. Don't let me manage space here. Or what do you think? I don't want to manage space here. Let's come to the other side here. Let's come and clean. All right. So let's now start substituting, right? So to start substituting, I can say that 2x minus 5 divided by, what's that now? X minus 1, then open another bracket here. What do I have? X squared plus what? Plus 9. Then everything is equivalent to, what's my A? My A is what? Minus 3 over 10, open bracket, 1 over x minus 1. Yes or no? Okay, good. Then plus, I think B is 3 over 10 x plus, what's the next one there now? C, which is what? 23 over 10 divided by what? X squared plus 9. Okay. Then from here, what can I have? See the same thing as minus 3 over 10, open bracket, 1 over x minus 1. Are we together? Then plus. Now, I hope you know that it is very, very easy for me to remove 1 over 10 here. Then I will have what? 3x plus 23. Over what? X squared plus what? 9. Are we together? Okay. Then from here, I can now have integration of 2x minus 5 over x x minus 1, and this is what? X squared plus what? 9 dx. And everything here should now give me integration of this answer here, which is what? Minus 3 over 10, open bracket, 1 over what? X minus 1 plus what? 1 over 10, open another bracket, 3x plus what? 23 divided by what? X squared plus what? Plus 9. Are we together? Dx, everything here. Then here, this is the same thing as bringing out this one to give me minus 3 over 10, integration of what? 1 over what? X minus 1 plus 1 over 10, integration of what? 3x plus 23 divided by what? X squared plus what? 9. So this one here is what? Is dx. The other one here is dx. Then, so from here, I have minus 3 over 10. If I integrate this, I have ln of what? X minus 1. Then plus 1 over 10. I can break this integration down to 3x over x squared plus 9 plus 23 over x squared plus what? 9 dx. Are we together? And so from here, alright, let's do it this way. Remove 1 over 9 out straight up, 1 over 10 out straight. Although let me remove it like that straight. So let's keep on working with it. Abi now. So if I keep on working with it, now I have minus 3 over 10 ln of what? X minus 1 plus 1 over 10. So now here I integrate 3x over 2x squared plus 9. So normally I was supposed to have 2x, but I have 3 there. And I can say that will give me, open bracket, 3 over 2, right? That will give me, open bracket, 3 over 2 ln of what? Ln of x squared plus what? Plus 9. Are we together? Now plus 1 over 10 multiplied by what? 23. Now the goal is, how do I integrate 1 over x squared plus 9? I don't know if you have heard of trig substitution. So by trig substitution, if I integrate this one here, the answer I will have will be tan inverse of 3x. That's what it should be. So tan inverse of 3x. Then don't forget your arbitrary constant of what? Of c, right? So is there anything, this thing looks too long for me. Don't like it. Let's combine everything. Let's combine everything. Is it combinable? I don't think so. So let's just leave this as my what? Final answer. I don't think it's combinable. Are we together? Okay, good. So that's that about that. So there are a lot of different kind of forms of quadratic equation that you can have. I mean, of integration that you can have. So the next one we'll be looking at now, we'll be looking at application of integration. As the next subtopic, we'll be looking at, although I might not take a lot of examples on it, we'll be looking at what application of what integration. Okay. So So from here, the next thing now is okay, applications. Applications of integration. So there are a lot of places that it can be applied to. Now, first of the place can be applied to, it can be applied as what? Area under curve. Under curve. You can use that in area under curve. You can use it also in what's it called? You can use it in dynamics. Using dynamics, or better still, let's call it kinematics. Albino. We have it in kinematics. Which other part do we have again? What do we have application of integration again? But those are the basic parts. The two basic parts. So now, how do we deal with area under curve? Now, probably we have some example. Probably we have some example that states that, okay, can I get an example from area under curve from my head? No, I don't think I can. Do you have, is your manual here? Okay, good. So let's work with your manual. Thank you very much, ma'am. So, working with this. Okay. We so it looks as if your manual did not talk about it. I am sorry. Probably when next we meeting, then if you be around, remind me. I'll look at the applications. Your manual doesn't have anyone on it. Okay. So, but these are the basic area of integration that we have. So if you have any questions that we have, you can just probably bring out before we move on. Because the next part we are moving on to now is a little bit tedious, and I will require everybody to stand up. You can just help. Sorry, I love you all. Eh? No, it's not easy. Yeah. You see, look at the... Do you have one? All right, thank you. Okay, yes. The question is find... Okay. That's something like this. Don't worry. I can still give you the opportunity now. But the ones you are entering into, I won't give you the opportunity to sleep again. If you sleep, you stand up on your chair and you continue writing. I think that's what we do. Now we have this area that's they ask us to find area on that curve. And whenever they ask you to find area on that curve, it's also they're mostly specific about you getting the definite integral of that curve. I get on pencil like that. So that is why you have those 2 points here. Definite integral. So let's for the definite integral. And don't forget, the greater one will be up, the lesser will be what? Will be down. So what's the greater? The guy is 2, the lesser is what? Minus 1. And what do I have here? I have 3x squared plus what? 14x plus what? 15. Everything here is what? Dx. Then by here, if you integrate here, then what will I have? Then I hope I will have 3x cubed divided by 3 plus what? 14x squared divided by 2 plus 15. What is that? 15x, right? And everything here, okay. Then it's bounded by what? 2 and minus 1. And I think by the end of the day here, all I have here, I'll have x cubed, right? Plus 7x squared plus what? 15x. Then I'll be putting 2 and minus 1 inside. Abina. So if I put 2 inside, what do I have? I have 3 to the power 3 plus 7 2 squared and plus 15 to the power 2. Then everything minus, putting minus 1 now. Minus 1 to the power 3 plus what? 7 minus 1 squared plus 15 minus 1. So if I do this, so what do I have here? I have 8 8 plus 28, right? 8 plus 28 should give me 36. 36 plus 30 should give me 66, right? 66 minus, let's see, so what do I have here? Minus 1 plus 7 is going to give me 6. Then 6 minus 15, that should give me 6 minus 15 is 6 minus 15 is minus 9, if I'm correct. Then if you have everything together here, what will you have? We have what? 66 plus 9, which should give me about 75 square meters. Doesn't apparently like that. Does note that whenever you are dealing with area under curve, basically, although there are some functions and sometimes that the questions might be tampered with a little bit, just a little. But also that whenever you are differentiating or you are dealing with area under curve, you're just asking to find what? Definite integrals. Asking to find the definite integrals at that boundary that they have given you. Are you going to apprentice like that? So please note it. Please, it is very, very important for you to what? Very important for you to note it. All right, now we want to upgrade our game. So I think we've come to the end of review of differentiation and integration. So I advise you to go home and practice more questions. Get as many questions as you can get and lay hands on them. So if you know that the person that is sitting beside you is making you sleep, stand up and go and sit down another place. No, because no one is sleeping in this next class, because the next class we want to enter now is partial differentiation. Another partial differentiation is a little bit it's easy, but if you don't get it on time, you get confused. Or partial differentiation, or partial derivatives. And it is also the broadest topic in this course so far. The broadest so far. Now partial differentiation or partial derivative. Now I believe everyone here was present when I was doing the class on differentiation. Ish. None, not all of us. Okay, because I love you, I will do it again. Now partial derivative. So this partial derivative, and on this partial derivative, so let's do a little bit of jerking of our memories by doing implicit differentiation. Now, how do we recognize something to be implicit? We know it to be implicit if and only if the function is written in such a way that you cannot separate x from y. That's number one. And the other way you can note that something is implicit is that if it's written in such a way that the power of x and the power of y is also what? Is also equal to each other. You get what I'm trying to say like that. So that's implicit. Can we get one? Let's form one. So from forming one, you can have 3x squared minus 4y squared plus 20xy equals to 0. Okay, I think let's start with this. I think I hope you know that from here there's nothing on earth that can make me or can give me the ability to separate x from y here. Abi now, x and y cannot be separated. Abi now, although I can find a way to separate it, but at the end of the day I will end up not separating it because it can't be separated. Now let's now differentiate normally. So I need one to differentiate. How do you differentiate? Differentiate what? With respect to x. Yes or no? Let's start. So we differentiate it what? So we differentiate with respect to what? To x. Now for me to differentiate with respect to x, so that means I will start picking the terms one by one and differentiate by x. I'll get in it. And if I hope you can hear me. Okay, good. Then if I want to differentiate y, then at the end of the day I'll be left with what? Adding dy dx to that y that I want to differentiate, which is showing the reason that I'm doing it what? Implicitly. Do you understand what I'm trying to say like that? Okay, good. So from here, so let's differentiate. If I differentiate 3x squared, what do I have here? I have 6x minus, what this one give me? 8y dy dx all together. Now plus, now this 20xy is more or less like is compound. So let's use product rule to differentiate that. You have 20xy, and this 20x is your u, your y is your v. So you have 20x. If you differentiate your y, what do I have? 1 dy dx, or dy dx, any one. Then plus what is your v here? Y. What do I have here? 20. Yes or no? Then if you open your bracket here, what will I have? You'll have 20x dy dx plus what? 20y. So put that inside these spaces. So I can have this one to be what? 20x dy dx plus what? 20y equals to what? 0. So from here, you can just simply collect what? The like terms together. By collecting the like terms together, okay, how do we do that? Alright, okay, let's do it this way. Let me take this two to the other side. Let me take your y dx to the other side. You can have 6x plus 20y equals to what? 8y dy dx minus 20x dy what? Dx. And 6 here is the same thing as we have 6x plus what? 20y equals to what is common here? What is common here? Yeah, dy dx is common. So what do I have? I have 8y minus what? 20x. All together. So from here, I can now say that my dy dx in this case here will now be giving me what? 6x plus 20y divided by what? 8y minus what? 20x. So I think the unit that is common here is 2. So if I remove 2 from numerator and denominator and divide, I think at the end of the day I should be left with what? 3x plus 10y equals to 4y minus 10, yeah, 10x. I wish I have something that can make me reduce it, but there's nothing I can do here. So now, okay, this is just a review on what? Implicit differentiation. I get what I'm trying to like that. But in this implicit differentiation, the next topic we are going to, which is partial differentiation, also has its working principle like implicit differentiation. Right? It has its working principle like that. So I'm waiting for you to finish writing so that we continue. I guess you'll be done by now. Alright, good. Let's continue. So continuing, so what do I have here? So now let's now talk about partial derivatives. Now partial derivatives, what do you understand by partial derivative? Now, the first keyword that is there is what? Is partial. What do you understand by partial? Partial. What is partial? What does partial mean? Oh, yeah, now, what is partial? Partial means actually for you to, because of someone, you do not do what you say you want to do again. I'm not joking literally. But partial means that you are being biased. That is what you are doing to one, you are not doing to the other. I get some terms like that. That is also the same concept of what of this partial derivative. It means you want to differentiate one and you want to leave the rest, and probably at the same time you differentiate the rest and you leave the first one. I get one terms like that. So that's partial differentiation. I get in it. That's number one thing I wanted to know about partial derivative. And the second thing I want to know about partial derivative is that partial derivative has as many independent variables as it can have. It's not like on your normal differentiation that has only one kind of what variable, which is basically x, y, or probably want to change it is t. And if they change it to t, that means all the terms that you have there will be only what? Be only t. Yes or no? Okay, good. So since that's going to be the case, now and we have talked about, so please just note that partial differentiation is a kind of differentiation whereby you can have as many independent variables as you can have. You can have 3, you can have 4, you can have 7, you can have 30. But it's what? It's like that. So now, the first thing is that let's now look at introduction first. So let's look at introduction. And again, there's this basic notation in it. I don't know, this thing that looks like an incomplete R sound. Phonetics, they call it schwa sound. I don't know whether that's how it is. What is it, schwa? The schwa sound. But it's not schwa sound now. Schwa sound has this slash on top. Let's try schwa sound. Yes, inverted 6, all the best. So whenever you're dealing with partial derivative, you'll be dealing mostly with what? The schwa sounds. That will be your symbols. I guess I'm pronouncing like that. Okay, good. So now let's see now number 1. You want to find, now this is what we're up on. So number 1, let's say that you have u equals to this same equation you have on the board, 3x squared minus 4y squared plus what? 20xy. Let's say that we have this kind of stuff as a stuff. So first thing first, now the question is how to differentiate. So the first derivative here, which is u underscore x, or better still written as partial u partial x. So that's what it means. So that means that this differentiation will only favor what? Only favor x. And then other thing apart from x will serve as a what? As a constant. You get what I'm trying to say like that? And how can you know that if you differentiate a constant, what will you have? You have 0. Okay, that's nice. Then another thing again I want you to know is that whenever you have a constant and a variable matched together, what do? You write out your constant first and you differentiate your function later. Yes or no? Because that is the reason why by differentiating x squared you have what? 2x. No, not even x squared now. That's the reason why if you differentiate 10x squared, you have what? 20x. Because first of all, the 10 that was in front of it, you did what? You kept it somewhere and you differentiate what? X squared. And if you differentiate x squared, you have what? 2x. So that 2x that you had there, multiplied by the 100, give you what? 200x. Well, I'm trying to like that. Okay, good. So now let's talk about this. Now, partial u partial x, or better still known as u underscore x, is talking about the fact that everything I want to differentiate there is only what? Is only x. Is only x. So from here, from this only x here, the next thing I want to do now, so let's differentiate only x here. So all I have here, I'll have 6x. I can't differentiate minus 4y. Give me what? 0. Then plus, this one give me. Now I have 20y as a constant, right? So you are writing your 20y outside first. Then if you differentiate x, what do I have here? 1. Are we together? Then from here, what do I now have? I have what? 6x plus what? 20y. That is the same as what? Ux. So now the next one is what? Is your uy, which is the same as uy, or better still, partial u partial y this time around. So whatever you're differentiating is just only in favor of what? Y this time around. So I can differentiate 3x squared. So the next time I differentiate is what? Minus 4y squared. So if I differentiate minus 4y squared, what do I have here? Minus 8y. Then plus, what is a constant here? 20x. Then if I differentiate 2y here, what do I have? 1. Happy now? Then if you open your bracket, write your plus first, then you have 20x minus what? 8y. Good. Another thing I want you to know, another thing that is the power is that 20x minus 8y, 20x minus 8y is that number of independent variables that you have. Determines how many type of answers you will get from your question. The number of independent variables that you have will tell you how many numbers of what answers you will get. So probably we have a dependent. If you have a question that's probably how many independent variable, maybe let's talk about it. Maybe 8 dependent variables, independent. How many answers will I have? I will have 8 answers. I guess my point because I'll differentiate partially with respect to all those terms that we have there. Alright, good. So let's upgrade our game. Now, to upgrade our game, so let's say probably you want to have, should you give it another name? Let's call it V. Then from V, let's call it what should we call it? Let's give it let's give it something interesting. Let's say AB plus AC plus BC. Abi now? Okay, good. From what I have here, how many dependent variable do I have? How many independent variable do I have? I have 3, which is what? A, which is what? B, and also what? C. Then at the same time, so let's now start. So partial, no, I don't want to use this partial this time around. I want us to get used to writing this, your V's and the subscripts, because that is likely what you are likely to see in your exams. I get one point like that. So I can say that V underscore A means that I want to differentiate A and B alone. I mean, I want to differentiate only A alone. I getting that? So from here, this is where A. So if I differentiate B, what do I have here? 1. Then plus what do I have here? C. Then I have 1. And I think that's all. And if you open the bracket, then you have what? B plus what? C. Do you understand what I'm trying to say like that? Then the next one, VB. VB now. So what do I have? I have A open bracket what? 1 plus what? What do I have here? C open bracket what? 1. And then of the having what? A plus what? A plus C. Right? And the last one, which is what? Which is VC. Not VC of hotel, VC. VC here is now I have A open bracket 1 plus what? B open bracket what? 1. I guess I'm trying to say like that. From here, VC here is equals to what? A plus what? B. So I have successfully what? Differentiated. Then someone I'm trying to say like that. So good. That's that about that. So let's increase the complexity of the stuff. But at the same time, let's just continue working. Ready? Ready? Okay, good. So from that, this is semester break now. Abi now. We learn to deploy him today, and we still have time, safe. Abi now. The fact that we're just flowing in our flow, it's making it interesting. I'll get on a branch like that. So now, number 3. Let's make it a little bit more complex. Right. So let's give it T. T this time around to give me ABC minus A squared C plus B squared C plus AC squared. Okay, good. Then from here, then what do? Then, yeah, how many independent variables do I have? Independent variables I have 3. Since I have 3, so that means how many derivatives do I have there? I have 3 derivatives, good. So I can say that T underscore A. So I think T underscore A here will not make it look interesting. Let's write partial. For me, partial T, partial A. So that means I'm differentiating only A. So what's the constant here? BC. You differentiate A. What do I have here? 1 minus C is a constant. You differentiate A square. What do I have here? 2A. Then plus what do I have here? C square is a constant. Differentiate A. You have what? 1. Then from here, I have BC minus 2AC plus what? C squared. And I think by God's grace, I think what is common here? C on this side is common. So C here will give me, okay, let me remove my C. Then what do I have? B minus 2A plus C. I'll go together. I'll give you a partial T, partial A. I'll get in. The next one we are doing is what? Partial T, partial B. So partial T, partial B. So can we jump now? Can we jump? Okay, let's jump. So partial B, partial C is what? AC plus 2BC. Are we together? I have C equals to A plus 2B. Right? Don't get. No? I'm differentiating respect to B now. There's a B here. Now I'm left with what? AC. And differentiating this B squared here, which will give me what? 2BC. Right? Okay. Then from here, we can move your C. I think that's what we have as a final answer. You understand that? Okay, good. The next one I want to do here is partial T, partial C. So partial T, partial C here, in this case. So, ready? So that's going to give me AB minus A squared plus B squared. So, let me just leave it like this. I guess I'm trying to say like that. Do you understand? Look, you want to factorize. Okay, plus A. Plus 2AC. Okay, let's continue, right? So, continuing. So, we've done basic introduction. Let's now move on to higher derivatives. Higher derivatives, okay. Why does this derivatives away derivatives? Now, okay, that derivative is when instead for you to have your ux, your uy, you'll be having them in terms of squared. Second one that the differentials. So, okay, let's look at this. Let's look at y equals to 4x raised by 3 plus 4y raised by 3 plus 30x squared y minus 8x squared minus 8y squared. Then some from here, out together. Let's differentiate. So what is, okay, let me use y now. Let me use w. Now, w complement, that is if I call w now. So, or what am I saying? W underscore x. So, if I measure respect to x, so what do I have? I have 12x squared plus what? 60xy minus what? 8y squared. Yes or no? Now, the w of y. W of y now, this limit only y, which will be minus 12 y squared plus 30x squared minus what? 8y squared. Abi? No, it's now 8. 16xy. Are we now? So if I write this wy here, what do I have? I have 30x squared minus 12y squared minus what? 16x what? 16xy. Are we together? Okay, good. So this time around, if you are now having something that is like not the normal, so probably you now have wxx, and wxx is equal to same thing as partial w, partial squared w over what? Partial x squared. That's the next thing. So wxx equals to that. And what does that answer mean? It means that you want to differentiate your wx with respect to what? Respect to x, yes. This one is either written like this or you write it like this. And this means you want to, what does it mean? As I said earlier, you want to differentiate wx with respect to what? Respect to x. Now what's this is my wx. So what am I differentiating? I'm differentiating with respect to what? To x. So this should give me what? And 4x plus what? 60y. Are we together? And next one. Or partial squared w over what? Partial y squared. So that means we want to differentiate wy with respect to what? Y. So differentiate w by respect to y. So we have minus 24y minus what? 16x, right? Now I think the next person I've not paid now. Okay, wxy, and this wxy is the same thing as saying partial square w over what? Partial w, no, partial x partial y. That's what it means. Partial square w. So it means that we differentiate wx again with respect to what? With respect to y. Yeah. wxy means you differentiate wx with respect to y. So let's differentiate wx with respect to y. So what do I have there? wx with respect to y. So what do I have? I think I have 60x minus what? 16y. Yes or no? Then I think finally is what? wyx. And for wyx, it means you are taking. It means you are taking what? You are taking partial square w by partial y partial x. I'll get some pencil there. So that means we want to differentiate wy with respect to what? To x, which are the same. I'll give you edge 60x minus what? 60y. Do you understand? Are you sure? Are we sure? So that's just one example, please. I just do to note them. They're a very common piece in your exam. Common piece. So let's do one more example, and we have how many answers there? We have 4 plus 4, which is what? 8 answers. Okay. So, another example. Another example. Okay. Okay. So from another example, let's look at 8 x minus 20y squared plus 15 x squared minus 8y plus 2t. Then let me use t now, let me use k. Yeah, since I have this one that is equal to k this time around. So from here, what do I have? So let's just differentiate. So let's look for what? Kx all together. So kx here. So if I differentiate kx means I'm only differentiating with respect to what? Only x. Yes or no? What do I have here? I have 8, and this is what? Plus 30x, right? Is there any other thing I can differentiate there again? No. So what is ky? Ky is equals to differentiate with respect to y, right? Minus 40y minus what? 8. Then kxx. Differentiate this answer with respect to x, which will give you what? 30. kxy. Differentiate this answer with respect to y, what do we have? 0. Now kyy. Differentiate the answer with respect to y, minus 40. Then kxy. Kyx, which also give me what? 0. Do you understand? Okay. So, okay. We have as many of the questions there as you can have. Are we done writing? Okay, let's write fast. Welcome back. I'm waiting for us, so I can write. How many examples have we done? I've done how many like that? We've done 2. Okay, let's look at another example that we can do. But this time around, let's make the example a little bit challenging. Are we together? Let's make the example a little bit challenging too. Let's differentiate this time around. Yeah, I want to differentiate. Okay. Y cos AB. Yeah, you have that. I want to differentiate that. Y equals what? Cos AB. That's what you want to differentiate. So differentiate y equals to cos AB. So that means the first thing I have to do here is that you have to. How many variables do I have here? 2 variables, obviously. Okay, good. So from here, let's now start differentiating here. You can see that YA should now give me. I hope you know that that's going to give me minus B sine AB. Yes or no? Yes or no? Are you sure? Okay, good. The next one, YB equals to what? Minus A sine AB. Now, Y. Yes, minus A, thank you. YAA. YAA means you are differentiating respect to A again. What do I have again? Minus B squared cos AB. YBB. So YBB means you are differentiating respect to B now. What do I have here? Minus what? Minus A squared cos what? AB. The next one is YAB. YAB. So if I yab this question, YAB, what am I supposed to have? Minus B squared man. Then next one, YBA. YBA there will now be, I want to mention this one, respect to what? To A. Then I'll give what? Minus A squared cos what? Cos B. Have you now? No, this is ABO. ABO. I was good now. Okay, so from here. Okay, so I think with that, I believe that there's no differential question that we can, there's no PD question, this partial differential question that we can see that we can solve now. Okay, I have ones from my book. Okay, let's look at them. All right. Yeah, we have a lot of them here. Wow. Some of the questions I say, I have not learned their technique, and most of them are asking you to prove. I want to do CBT not ask to prove. But I'll still work on it too. Keep it. You get. But based on what we have been working so far, I've not seen anyone. The ones that are here approving. How we getting it? So now we have done all of these ones now. Let's move on to another subtopic, which is can I rule this part? Okay. So the next one here is what? Total differential. And total differential. So peradventure, let's create a law concerning this total differential. Are we together? Okay, good. Now total differential, let's say if you have a general, let's say U, which is a general function, which is a function of x comma y, or as many functions as you can have. Suppose U is like this, and you want to find du. Du equals to partial U partial x dx plus partial U partial y dy. Partial U is plus or minus partial W plus dot plus or minus. that's this kind of scenario that you have whenever you have a what? Total differential. You can write it down. So from here, so let's have an example. So find the total differentials finding total differentials of the following. Alright, so number one, let's say, okay, let's give it k equals to, what should we give it like that? ABC minus AB plus C by 2, T equals to 4, T cosh Y. What is it? This K. Alright, so I want to calculate the total differential of all of this. So from total differential of all of these ones now. So the first thing that we have to know is that we have to first of all know how many variables it have, then we can continue from there. Okay, so number one. How many times have I even dissected the board self? So let's start. Number one. So now we are looking for what? Decay, right? Okay, decay is your total differential, okay? And for your total differential k now, the next thing you have now will be that, how many variables do I have there? 3 variables. So that means this is my formula will extend up to what? My third variable, right? Now first of all, so if I want to form the formula here, then forming the formula here, this one should give me partial k dA, right? Plus partial k partial b dB plus partial k partial c dc, right? Okay, good. So from here, so let's now look for partial k partial a. The partial k partial a here, the one we have on partial k partial a will give me bc minus what? Minus a. I mean now, it's not a, bc minus b, and partial k partial b now should give me what? AC minus a, and partial k partial c should give me what? AB plus what? 1. Put all of this one inside this formula. I say that the k equals to what? So bc minus b dA plus AC minus A dB plus AB plus 1 dC. Whatever I've written down there is the what? Total differentials. Are we together? This is dC now. That's the B. Do you understand, please? Okay. So please just know the formula. Once you can know the formula, you can form formulas, and that will not be a big problem. Okay. Yep. Yes, that's the answer. Looks weird, I mean. And that's how the answer looks like. Now, the other thing that you can do to that question is probably if they give you values of probably A and give you values of B, or if they give values of C, and from there you can just what? Substitute. And sometimes that they can ask you to find the total differentials. Please, just note it's very, very important to know the wordings, because I've heard people tell me they've seen this type of question in the exam hall. Very simple, but they forgot what to do about it. So I don't want to breed forgetting people. So pay cognizance to the formulas. Do you understand? Are we sure? Okay. And from here, okay, so now let's get number 2. Number 2. Are you tired, Ni? Are you tired, Ni? Let's continue now. Hi, boy, where are you going? So, number 2 is, now we have k here in number 2. So we have k here is equals to, k is equals to what? 4 sine 3x cos y. How together? We have 4 sine 3x cos y. She can find it like that. Now, so from here, so what do I have to do now to differentiate? So, first of all, it's very, very important for you to form your what? Form your formula. I will get my apprentice like that. Form your formula. So, what's the formula here? So, the k here is equals to what? Partial k, partial what? Partial x dx, right? Plus partial k, partial y dy. Do you understand what I'm saying? Okay, good. No. So from there, let's find partial k, partial x. So partial k, partial x, it means you want to differentiate this answer here with respect to x, right? Anything apart from x is what? Is a constant. Yes or no? So what? So if I differentiate x in this place here, this is a constant, right? So if I differentiate, what do I have? I have 12 cos 3x cos y. Yes or no? And also partial k, partial y. Yeah, should now give me, what is the next one? So I want to differentiate only this one. So I have 4 sine 3x as a constant first, put together, and if we differentiate cos y, this answer is what? Sine y. Now I've got all the formulas I need. The next thing I just have to do is what? Slot it inside my what? My original formula. So the k equals to 12 cos 3x cos y. Are we together? And everything here is what? Dx plus, what do I have here? 4 sine 3x sin y. That's what? dy. That will be the answer to the question. Do you understand? Alright, are we done writing? Okay, good. So number 3 is when you have, and then number 3 now you have u equals to what? 5x squared minus 4y squared. So don't not take us time, right? So can you tell me what my du will look like? Du straight up without stress will give me what? 10x dx minus 8y dy. Yes or no? Without stress. Right? Okay, good. That's nice. Alright, so that will be that about that for total differentials. Do we get? Do we get? So, yes. It's already daybreak already. Let's continue. So, the next thing here. Okay, so we've done with the first part. So the second part on that total differential that I want to look at is what is that now? Yeah, let's look at your chain rule. Yeah, let's look at your chain rule. Here, du. So chain rule, chain rule, chain rule, chain rule, chain rule. So now chain rule, I don't know. It has a very formula, a very funny formula like that. But let's walk through to it all together. Are you ready? Okay, good. So chain rule. So I think I thought some people to give it one funny definition then some times ago, so that they can remember it, right? Okay. So chain rule. So now, if you have a general family of, let me call it, if you have a general family of, let me say U, I'll go to my pencil like that. U is defined in terms of X, Y, Z, W, K, whatever, as many functions as you can have. Are we together? And also, all of those functions, X is a function of T, while Y is a function of T, Z is a what? Function of T, W is a what? Function of T, then as many as we can have like that, like that, like that. I'll get on a pencil like that. Now, if you have this scenario, and the question asks you to find the U, the T, then the answer here is partial U, partial X, the X, the T, plus partial U, partial Y, the Y, the T, plus partial U, partial Z, the Z, the T, plus dot, dot, dot. You can have it as many, have it as long as you have, like that. So that is chain rule. But I think if memorizing the formula, I won't ask you to memorize it. Now the best thing I can ask you to do is find a way to master it. But let me teach you a way to master it. Are you ready? Okay, now. So let's imagine that this my U is a father. Are we together? Please look up, look up, look up, look up, look up. You're right. So let's imagine that my U here is a what? Is a father. Yes or no? And that father gave birth to as many children as he can have. I'll get one pencil like that. This U is a what? Father. He gave birth to what? As many children as he can have. I'll get it. And those children of his give birth to only one type of child. We are ọkùnrin nìkan, àbí obìnrin nìkan, àbí, you get what I'm trying to say like that. So that's it. I said that imagine that you is the father that gave birth to children, then his own children now gave birth to how many type of child? Only one. Now this one here, the UDT will now compute the relationship between the father and his grandson. So how do we get that relationship? It should be father, first son, first son and what? And his own child. I get it. Plus what? Father, second son, child. Father, third son, child. Father, fourth son. Okay, I didn't write that one. But do you understand what I'm trying to say like that? So that's the easiest way you can use to remember the formula, because not only will you need it, I get what I'm trying to say like that. If I say you should cram it, they can change variables for you guys and you look confusing. You get what I'm trying to say like that. Just note that whenever you have a function like this that has only one type of function, then you have this as your answer. I'll give you questions. Don't worry, I'll give you questions. Now, this chain rule is in two parts. Now, the second part is this. So now suppose you now have u, which is equal to a function of the same thing, x, y, z, as many probably w and k, then comma dot dot dot. Yes, are we together? Then, but in this time around, those people did not give birth to one child. They probably they did more than family planning, or family planning did mistake, or they did mistake, or mistake shall happen. All of them now give birth to two. Function of t and k. No, I don't want k. Let me give a and b. Then y also give birth to what? A and b. Z also give birth to what? A and b. Are we together? Now, so if I now want to compute the relationship between the father and the first child that the son will give birth to, so let's compute that. So that will be partial u, partial a. I get it. That is the relationship between the what? Father and the what? First son. So how would that be? That would be father, first child, first son, then plus what? Father, second child, first child, then father, third child, first child. Are you getting it? Then you can continue as long as you can have it. Now, this is thus only what with the first child. So let's now move on to the second child. So partial u, partial what? Partial b. So what would that be? So that would be what? Father, first child, and what? Second child. Yes or no? Yes or no? Then plus father, second child, and his own second child too, right? Plus father, third child, and his what? His own child, right? So you can have it like that. So this is what makes up chain rule. Sometimes you can have chain rule as a single function, sometimes you can have chain rule as what? As double functions. And you can also have chain rule as a triple function if you want. So let me pick questions from your manual. Give me a manual. Right. I like this sister. Let me pick questions from your manual. So I want you guys to write what's on the board and and I would have loved to use this in your manual, but your manual is faded. Yeah, thank you very much. Let me use it's faded. Manual is faded. Just sit down, pass it to the front. Okay. Away. Okay. Okay. All right. Let's see if I have perfect examples for that. Are you ready? Okay. So examples. Let's deal with 3 examples. But as I told you, the most important thing you have to do is what? First of all, you have to know how to create your what? Create the formula. That is the most important thing, because if you don't know how to create the formula, my dear, the way you're doing is play. I do what? Play. So let's continue. So I think, how many of us are with this manual? So, okay, if you are with it, probably share with the person that is with you. Do you have anybody at the row at the back? That's this manual present here. Okay, let's write this question then. Okay, at the page, I don't know, is the page the same or is it different? Okay, page 26, and I think I want to call some questions there. All right, first question I want to call page 26. Where's the question? Okay, come here. Number 28. So says that if u is a function of x, y, and z, which is defined like this: 2x squared minus yz plus xz squared, and x is written as what? 2 sine t, y equals to t squared minus t plus 1, and z equals to what? 3 exponential what? Minus t, right? Question said you should find the y dt at, is it the y, not the y now? The u dt at t equals to what? 0. Now let's look at this thing critically. Now, this is the general father, yes or no? Yes or no? This general father give birth to how many children? How many children did he give birth to? 3 children, which is what? Your x, your y, and your what? Your z. Yes or no? And those 3 children give birth to how many type of children respectively? How many type of children did they give birth to respectively? 1. It's not 2. Now, the reason why it is 1, it's not 2, because apart from t in your x, y, and z, there's no that letter there. So I can say that the only child that x, y, and z have is what? Is t. So from here, so now the thing is that we now want to compute the relationship between father and the only grandchild that the children will have. So how can we do that formula? First thing will be what? Partial father and his own first son all together, multiplying what? By his first son and his own child. I'll get in it. Then plus father and his what? Second son. Then his second son and his own particular son, right? Okay, sorry, this is how it should be. Now, okay, it's CBT. The writing does not really matter, so don't let me disturb you with writings. Then the last one here will be what? Father and what? Third child, then the third child and what? His own personal child. All together. This one here. An example. Don't worry, we are taking step by step. Don't worry. Calm down, you do double. I'll give you triple step. Now, so from here, I think the best thing for us to do now is now to start sorting in. Let's now start finding the variables. So the first thing I have to look for here is what? Partial u, partial x. So what is partial u, partial x? That means you want to differentiate function u with respect to x. Yes or no? Yes or no? And the differentiate function u here with respect to x. What do I have here? 4x. Yes or no? Okay, good. Then partial u, partial y. What would that give me? No. X is not done. 4x plus what? Z squared. Right? Then partial u, partial y. So partial u, partial y give us? Oh yeah, nice. Or partial u, partial y will give me minus z plus 2zx. Happy now? Happy now? Then the last one is partial u, partial what? Z. So what would that give me? Minus y plus, what did I do here? Minus z alone now. And this will give me plus 2xz. Yes or no? Yes or no? So from here I've gotten everything I need. And the last one I need here is the x dt. So what is the x dt? So let's start differentiating x with respect to t. So if I differentiate x with respect to t, what do I have here? 2 cos t. Happy now? Now, dy dt is what? 2t minus what? 1. Yes or no? Then the next one. Then the z dt, which is equal to what? Minus 3 exponential what? Minus t. I think this will be the softest class I will ever teach. I know raise up my voice, all of us just going, understand? Sekwe. Just joking, literally. You understand that part, please? Okay, good. So now I think we have sorted out all the ingredients. So the next thing I have to do is what? Start putting it what? Inside the food. So let's cook. Let's come and cook it there. Okay, stay empty, still one, right? Abi, you tired? Are you sure? I should stop. Should I stop? Are you sure? Abi, are you sure that you're not costing me from your mind that? Good and check, boy, you know? Alright, let's clean everything here completely. So now, next one. So I think I've gotten everything I needed. Have you know? So let's put everything inside that soup. What do I now have? I'll have du dt equals to, now what is the first thing I'm looking for? Partial u partial x. So what is partial u partial x? That is what? 4x plus what? Z squared multiplying. Now what is dx dt? Dx dt is what? 2 cos t, right? Then plus the next time is what? Partial u partial y. And what's partial u partial y is minus z. Now what is the next one that you have there? 2t minus 1. You have 2t minus 1 altogether. And the last one that you had there is what? What do I have? Minus y plus 2xz. You can write it as 2xz minus what? Y. And if I differentiate the last part here, what do I have here? Minus 3 exponential minus t altogether. So now from here, instead for me to stress myself by let me say, by opening the bracket, don't forget the question said that at what? At t equals to 0. So if the question asks you to put at t equals to 0, so just go straight to the point here and put t equals to 0 here. Yes or no? Then putting t equals to 0 here, you have what? Du dt equals to what? 4x plus z squared. Then here you have 2 cos. What would this one give you? 0, right? Abi now? Then plus minus z. Then you have 2 open bracket, 0 minus 1. Then plus 2xz minus y. Everything here is what? Minus 3 exponential 0. Yes or no? And if I open this bracket, so what do I have? I have 4x plus z squared. And everything here should give you 2. Yes or no? Because cos 0 is what? Is 1. Then what do I have here? I have plus, or okay, let me say plus minus z. Everything here should give me what? Minus 1. Are we together? Then plus, what do I have here? 2xz minus y. Everything here should give you what? Minus 3. Then if you open the bracket now, you cannot have, what is this? 8x plus 8z squared. No, it's not 8 now. Plus 2z squared plus z. Okay, let's say plus 3y minus 6xz. Yes or no? Because in this case, if you open the bracket with minus 3 times this will give you what? 3y minus and this will give me what? This answer. So at the end of the day, I have prepared the soup, and this is what? This is the food I have. Do we get what I'm trying to say like that? Alright, okay, good. Let's look at another example. Okay. Alright, so I'm coming. Let me see if I can get another one. Okay, this. Boy, I did now. Alright, so this is another question. So that if h of x comma y out together equals to what? X cubed minus what? Xy plus what? Y cubed. Are we together? Here, x is equals to alpha cos beta, and y is equals to what? Alpha sine beta. And the question here is asking you to find partial h partial alpha and partial h partial beta. Now let's start. The original father gave birth to how many children in this question? How many children the original father gave birth to in this question? Give birth to 2 questions, which is what? X and Y. Then how many children did X and Y respectively give birth to? How many did they give birth to? X and Y respectively give birth to how many type of children? Give birth to 2, which is what? Alpha and what? And beta. Yes or no? Okay, good. So let's now find the relationship between the father, the grandfather, and the first child. So I can say that partial h partial alpha, are we together? Why is the 2 symbol the same thing? Equals to partial h, father, his own child, are we together? Then his own child and his first child, right? Abi now? Plus what? What is this? Father and what? Second child, then his second child and his what? And his own child. Is that whole? Yes. Now partial h partial beta will be father and his first child, Abi now, and his first child and his what? Second child. Then plus partial father over second child, and second child and is what? Second son. Okay, good. So from here, let's now start looking for all the variables I want to impute in this thing. I want to look for all the variables. Now let's start by finding the variables. So the first variables I'll be looking for here. Let's start from partial h, partial x. So I'm going now to differentiate this function with respect to x. So what do I have? I have 3x squared minus what? Minus y. Are we together? Now the next one, which is partial x, partial alpha. So this is the only thing I want to differentiate. If I differentiate alpha, what I'll be left with? Cos. Like I said, that this one is what? Cos beta. Yes or no? Yes or no? Okay, the next one is partial h. What's that now? Partial y. So partial h, partial y gives me. So that will give me 3y squared minus what? Minus x. Yes or no? Now the last one, which is that now partial h. Is that whole? I think that's all. Then let's look for what? Partial y, partial alpha. So partial y, partial alpha will give me what? Sine beta. Yes or no? Yes or no? Then partial x, partial beta. So why is partial x, partial beta? So we are differentiating respect to this. What do I have? I can have minus alpha sine beta, and partial y, partial what? Beta. What would that give me? Alpha cos what? Cos beta. Okay. And from here, the next thing that you have here is now, let's put everything back here. So I can have partial h over partial alpha. Partial over partial alpha equals to what is partial h, partial x, which is 3x squared minus y. Now, partial x, partial alpha is what? Cos beta. Plus what is partial h, partial y? 3y squared minus x. Then what is partial y, partial alpha? Sine what? Sine beta. I think this is the best way I can leave my answer. And the next one is partial h, partial alpha. From partial h, partial alpha, you have partial h, partial, which is what? 3x squared minus what? Y. I mean now, it's partial h, partial x, which is this. Then multiplied by partial x, partial beta, which is minus alpha sine what? Sine beta. Then what would that give me? Plus. So what do I have here? 3y squared minus x. Then everything that I have here, partial y, partial beta is what? Alpha plus what? Plus beta. And so from here, if you multiply by minus, then you have your y minus 3x squared, open bracket of what? Alpha sine beta, I mean now. Then plus what? Y squared minus x. How is it together? Open bracket of what? Alpha cos what? Cos beta. So I believe this is the best way to leave my answer without expanding, right? I mean now. Right, so that's right. Are we? I'm going to please. Okay. This one, sorry? This one here. Okay, this one was just substitution inside this particular formula. Partial alpha. Okay. Sorry. Balanced. Okay. So while I wait, now we are done writing. So yeah, okay. Last question on this part then. we continue our journey, right? I'll be
I'll be tired.
Let's
Let's
continue.
continue the journey.
So the next part we would look at is something I won't use the word delicious, but I'll use the word delicious. Okay, let's just do something interesting. Now the second one is that they said, I want to change the question, and they said that
what is it now?
Okay,
yeah.
If
If g of x comma y comma z
is
is equals to, let me make it a little bit linear.
If
we have z equals to, okay, we have x squared plus y squared plus z squared, made it easy for you.
I have
something like this, and sorry, each of them now, and your x is written as 3r squared plus 2s.
Then y is equals to 4r minus 2s cube, and this third one here is z equals to 2r squared minus 3x squared partial g partial r equals to unknown partial g partial s also equals to unknown. So now, by now, we should be able to form the formulas ourselves without looking at the board. Okay, how about, let's do this. Let's make it more competitive. You form the formula in your notes, I form the formula on the board, first to finish. Ready? Not going to start. See cheats. You guys are cheats. I'm not going to start.
Cheating me. Ready. It's my game. I can call it start anytime I want.
Ready? Partial G, partial R. So, alright. Ready? Okay, I didn't ask you to solve. I just asked you to form equation. Form equation, I form equation. First person to look at. First one to finish. We look back. So as I will look back, I'll see the person I will look up. Are we together? Your time. I must say your time started now, so you can start. I'm not saying you should start too. I'm down now. You can start. So, okay. I think I'm done. Who's done next? Yeah. So this is the form. This is the formation. This is the formation of what you will have. I believe now that I don't think there should be anybody that don't know how to form the formula now. So you can check and confirm. Check and confirm. Okay. So with this. So let's get together. I hope all of us got it equally. Did we? Okay, good. So with this, we can all do what? Let's solve it together. So let's look for partial g, partial x, that is 2x. Partial g, partial y is 2y. Partial g, partial z is what? 2z. I think that's easy. Okay. Partial x, partial r is 6r. Partial x, partial s is 2. Partial y, partial r is 4. Partial y, partial s is minus 6s. Partial z, partial r is equals to 4r. Partial z, partial s is equal to what? Minus 6s. That what we would have. Abby? Please, can we check? Can we quickly check and we can have confirmations? Can we check and we can have confirmations? Can we check and we can have confirmations? Can we check? Can we check? Can we check? Can we check? Checking. Is there any problems? Probably I made a mistake. You can check the board, give me feedback. Okay, while I would wait, while you check, let me turn this to the side. What the heck? 7. Alright, so since nobody's talking, so I can say that that thing on the board is correct. Okay, good. So let's put everything inside. So partial g, partial r, everything here should give me what? Everything should give me what? Partial g, partial r should give me partial g, partial x, which is what? 2x open bracket. What is partial x, partial r? Partial x, partial r is what? 6r. Are we together? And then plus partial g, partial y is 2y. And partial y, partial r is 4. Then plus partial, that's 2z. And partial z, partial r is what? 4r. Then if you open this bracket, you have 12xr plus 8y plus 8zr. Then the next one is partial g, partial what? Partial g, partial s. I'll give you what? 2s. It's partial x, partial s. Partial x, partial s, you give me what? Partial x, partial s, you give me 2. Then plus 2y, partial y, partial s is minus 6x. Then plus 2z, now it's giving what? Minus 6x too. Yeah? Partial y, okay, minus 6. Partial y, partial x is, okay, minus 6x squared. 6x squared, so what do I have here? I have 4x minus what? 12x squared y, right? Minus what? 12x z. That'll be that about that. Squared, yeah. Maybe it's cubes here now. And there's minus now. Where? Okay, so this x, okay, should be s. So this should have been s, and this one too. I think it's not x here, it's s. And that's x and z. Sorry, man has been wanting to write. So that's that. Now, the next part let's look at. I want to look at chain rule. Chain rule. I mean, okay, we'll look at chain rule now. I want to look at something that looks like chain rule, but it's not a chain rule. Rate of change. I'm waiting for us to write next to. Are we done writing? Oh yeah. Now I want to look at rate of change. Rate of change. Now, rate of change. So Okay, should we list the remaining ones so that you guys can go and read it up? So after rate of change, we do increments, then from increments, we do Jacobians, from Jacobians, we do extrema, from extrema, you do Taylor's of two variable. Not this today, not today. Not today. But you guys come inside
now.
And
Are you?
We've
Try
tried
now.
You have to one
again.
Today. With me. Do you know my goal for you guys is that at the end of everything, you should just finish all the course. I'm waiting for you, that's why I'm talking. You just finish every 2-1, then at the end of the day, just go to exam, go and write any exam you want to see, and go and guarantee your he. That's my anti-8. Alright, so the next thing we'll be looking at will be rate of change. Wait, I did rate of change in application of differentiation. If you were in that class, raise up your hand. Yes, yesterday. I did rate of change, application of differentiation. Okay, only 3. Damn it. Wow. Lucky ones. Oh god. Are we done writing? Chain rule. Okay, let's write these questions. Chain rule. Are we ready? Shall we start? Chain rule. Rate of change. Rate of change. We've done chain rule. So rate of change. I want to find rate of change. Okay. And if you notice in the first class I did about rate of change in differentiation, find out that all the variables I was talking about were only one variables. For those of us that were around, yes or no? Now let's talk about ones that can have 2 variables. Can we start? Okay. The rate at which the height of a cylinder is increasing is giving us, you can write the question, it's a question. The rate at which the height of a cylinder is increasing is giving us, the rate at which the height of a cylinder is increasing is giving us, the rate at which the height of a cylinder is increasing is giving us, are we there? The rate at which the height of a cylinder is increasing is giving us 2 millimeters per second when the radius is 10 meter, or 10 millimeters, sorry. When the radius is 10 millimeter, comma, also the rate at which the radius of a right cylinder is decreasing. Radius of a right cylinder is decreasing. Is giving us okay, it's giving us minus 4 millimeters per second. 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 Are we there? When the radius is 15 millimeters. When the radius is 15 millimeters. Now, full stop. Question. Find the rate at which the find the rate. Why did you drop in? I'm continuing. Find the rate at which the way I'm talking as if they asked me not to open my mouth, Abby. Find the rate at which the let's just have it like this. Find the rate at which the volume is either decreasing or find the rate at which the volume of the cylinder, yes, let's be more specific. Find the rate at which the volume of the cylinder is either decreasing or increasing. Find which attribute the volume of a cylinder is either decreasing or increasing. Do we get that? Oh, okay, good. Now the first thing first that we have to deal with now is the formulas. Yes, the formula. See, I don't know how you're gonna learn all these formulas they taught you in secondary school back. Okay, let me help you. Open to the back of everybody and write these formulas down. Let me write the ones I can remember. Let me tell you the ones I can remember. So the formulas that you might need in rate of change. Number one, volume of a cylinder is given as 1/3 pi r square L. I don't want to write on the board. It will spoil my something. I want to keep it. So volume of a cylinder is given as 1/3 pi r square L. Pi r square L. That is where your L is your slant height, and that's a cylinder. Sorry, that is a cone. Sorry, cone. 1/3 pi r squared L for cone, and that L is the same thing as what's your H. It's your slant height. Usually you call it L, you call it your H. Anyone. So the curved surface area or total surface area is the total surface area. I think that should be pi r L plus H. I'm not sure. Like pi r square plus pi r L. Yes. Square plus pi r L. That's that. Now the volume of a cylinder, I know that one very well. Very well. Volume of a cylinder is pi r square H. Volume of a cylinder is what? Pi r square H. The curved surface area of a cylinder is 2 pi r open bracket r plus H. The curved surface area. No, that's the total surface area. Sorry. The total surface area of a cylinder is 2 pi r open bracket r plus H. Now the curved surface area is 2 pi r H. How is volume? Curved surface area. Curved surface area. Have you gotten that one? Where did we stop? Where did we stop? Eh? I think that is pi r H now. 2 pi r H. But you can confirm those formulas. I'm not sure. Let's confirm them. Sir? I think 4 pi r H. I'm not 2 pi r H. I'm not sure, but confirm. I think it should be like that. It should be 2 pi r H. Then after that one, volume of a cuboid. Yeah, let's talk about the cuboid. Volume of a cuboid is length times breadth times height. Volume of a cuboid is length times breadth times height. The total surface area of a cuboid is length times plus breadth times height plus length times height. I'm speaking Spanish. Now, volume of a cuboid is LBH. That is length times breadth times height. Now, the total surface area of a cuboid is LB plus LH plus PH. Are we together? I think everything in bracket 2, yes, divided by 2. In the bracket 2. Now the volume of a cube is what? What's the volume of a cube? S cube. Yeah, the volume of a cube should be x cube, and the total surface area of a cube is x squared. Right, I'm seeing. I still have some formulas in my head. S cube. S cube, and the total surface area is 6x squared. Yes. Q is S cube or L cube. Anyone? S cube or L cube? Cube. Multiply by 3. Okay, which formulas again do you need that I'm supposed to give that I've not given you? And everything multiplied by 2. So that's the important formulas. Can we now start? Okay, now what formula did my question ask you to find? Did deal with? What did they ask you to deal with? I know it's a cylinder. What part of cylinder are you dealing with? I know it's a cylinder. What part of the cylinder are you dealing with? Volume of a cylinder. I just stated the volume of a cylinder that V is equals to what? Pi r squared H. Now from this formula, it is obvious that I have two variables there. I have R and I have what? h. Then don't forget that the question is asking me to find the rate at which the volume of a cylinder is either decreasing or increasing, and I think that is giving me dv dt. Abi now? dv dt. So if I want to compute the formula dv dt, I think if you came to that class, this one should not be a new thing, it's just an extension, addition to it. dv dt now should now be, what is that? Partial v, partial r, dr dt, plus partial v, partial h, dh dt. Just like the ones we did, but this time around we're just adding one more variable to it. I'll get what I'm trying to say like that. You get it. So from here, let's start getting our parameters. So what is partial v, partial r? Partial v, partial r is what? Oh yeah, now, with respect to r, which is what? 2 pi rh. Good. Partial v, partial h is equal to what? Pi r squared. Abi? Okay, good. So the next one is, I think I've gotten everything I needed. Now, next one is now, let's now look for what? Dr dt. Now, dr dt is the rate at which the radius is what? Either increasing or what? Decreasing. What did the question say? Is my radius increasing or decreasing? Is my radius increasing or decreasing? Sorrow now. You have book in your front. Talk. Radius. 10 mm. Voila. Call my question for me, please. Fast forward to radius. Fast forward to radius. There's something that you're supposed to say before that. Good. Decreasing. That's what I'm asking now. What's not doing? Decreasing is what? Minus that. What call? What's the decreasing rate? 4 mm per second. The r dt is what? I mean, not the r now. The h dt. Is it increasing or decreasing now? Is it decreasing or increasing? One book is in your front that you cannot read like this. I don't understand. Decreasing. No, it should be stated. And I said it, that is either decreasing or increasing. So h here is increasing. At what? And now, that's the r dt, the rate at which the radius. That minus is telling you that that radius is what? Decreasing. The positive is telling that the radius, the height is what? Increasing. Are we together? Then from that part, the next one that you have to do is what? You can call your friends too. And the next one is that, what's your r? Your r gongon, what is the value of the r gongon that you will have? 10 millimeter. Abi? Now what is your h gongon? H is what? 50 millimeter. God. When you have book open in your front, I cannot read question. I don't understand. Then the v dt. Now, so what is this? What is your partial v partial r? That is what? 2 pi rh. Now, what is the r dt here? Minus 4 plus, what do I have here? Partial v partial h is what? Pi r squared. And what is the h dt here? Plus 2. Yes or no? And at the end of the day, what do I have here? I have minus 8 pi rh plus what? 2 pi r squared. Then from here, minus 8 pi multiplied by, what is my r? 10 times what? 15 plus 2 pi, and my r is what? Times 10 squared. So 8 times 10 is what? 80. 80 times 15, that's a very big number. 1,000 what? Tell mama sorry. 1,200 pi plus 100, 10 squared is what? 100. 100 plus, that's what? 200 what? Pi. Then what will be the answer here? Minus 1,000 pi Abi now, by centimeter, it's not centimeter this time around, but it's what? Millimeter cube per what? Per seconds. That is the rate at which it is decreasing. I get what I'm trying to say like that. Okay. Okay, start for 6 minutes. All right. So another question. Another question. Another question. Okay, I'm coming. Means I'm waiting. Okay. All right, another question. Quickly, briefly, interestingly. So now, if the rate at which, are we together? There's what problems now? If the rate at which, okay, if the rate at which the length of a cube, yes, if the rate at which the length of a cuboid, if the rate at which the length of the cuboid is increasing at, if the rate at which the length of a cuboid is increasing at 2 millimeter per second, when the length is 15 millimeter, comma, and the rate at which the breadth of a cuboid is decreasing, sorry, I might be fast, and the rate at which the breadth of a cuboid is decreasing is, wait, I'm going from my head, to spoil formation here. Okay, let me try. Now, if the rate at which the length of a cuboid is it increasing or quick? Increasing. Is it is increasing? Yeah, the first question. Is increasing. If the rate at which the length of a cuboid is increasing is, what is it? Call it again. 2 millimeter per second when the length is 15 millimeter, comma, and the rate at which the breadth, or is it breadth I called? Sorry, if it's not breadth, write breadth. The breadth of a cuboid, and rate at which the breadth of a cuboid, and rate at which the breadth of a cuboid is decreasing is 15 millimeter per second when the breadth is 10 millimeter. Are we there? 10 millimeter. Are we there? Full stop. If the rate at which the cuboid is increasing is, if the rate at which the volume of the surface area of the cuboid now, if the rate at which the surface area of the cuboid is increasing is, if the rate at which the surface area of the cuboid is increasing is, if the rate at which the surface area of the cuboid is increasing is 10 millimeter squared per second, are we there? And the, we have talked about length, we've talked about base, breadth, and the height, of the cuboid is 15. Why am I using 15? The height of the cuboid is number 1. Okay, it's 50. It's 50 millimeter. Determine the rate at which the height of the cuboid is increasing or decreasing. Did we get that? The problem is, everything I've just said, you cannot ask me to say it back again and I'll say it word for word. Sorry. I'm calling it from my head now and I'm forming it. If I'll say it again, that one I put increasing can become decreasing now. Okay. I think we all got the question. Are we together? Okay, good. So, did you get the question? Away. Ask, please. Away. Did anyone get the question? Okay, if you got the question, can you just let me call this for them, please? Okay, so now, what are we dealing with there? What are we dealing with there? What are we dealing with? What are you dealing with there? Good. Surface area of a cube is what you are dealing with. Not even a cube, it's a cuboid. And that's, let me call it as A. And A is given as 2 open bracket LB plus BH plus what? LH. Yes or no? That's the rate at which, that's the formula of what? Cuboid. Now, they told us that the A dt, the rate at which the area is increasing is area is increasing is what? Area low. Now find area. 10, that's 10 millimeter squared per second. Are we getting it? 10 millimeter squared per second. Now, what is from here? Let's compute the formula. Do you know that I can have dA dt equals to what? Partial A partial L dL dt plus what? Partial A partial B dB dt plus what? Partial A partial H dH dt. Happy now? Okay, good. So from here, let's start filling in the gap. What is this one here? 10. Partial A partial L. Differentiate everything with respect to L. What do I have? 2B plus 2H. Happy? Happy now? Now what is the L dt? That's rate at which length is increasing or decreasing. Is it increasing or decreasing? 2 millimeter, Abby? Okay. Plus, now, dA dB is what? 2L plus 2H. Breadth increasing or decreasing? Breadth increasing or decreasing? Decreasing. Minus, okay. What's the rate? 15. Okay. Now, plus partial A partial, that will give you 2B plus 2L. And do we have any question that has to do with that? No. This one is not using anything. This is what they ask you to find. DHDT is what they ask you to find. So here I have 10. If I multiply everything by 2, what do I have? I have 4B plus 4H minus 30L minus 30H. Now, plus what? 2B plus what? 2L. Everything multiplying what? The H, the T. Then for me, I can have 10. So put your formulas, put your B's and all inside here. I have 4. What is the B now? B is what? Jesus Christ. B is what? 15. Plus 4 is H. What is H? What is H? Minus 30. What is the length? Length is what? Okay, minus 30. What is height? 50. Plus 2. Breadth is what? 10. Length is what? 15. The H, the T. So I have 10 here is equals to, this is 40 plus 200 minus 450 minus 15 plus 20 plus 30. That's what? 50 the H, the T. Carry everything to the other side. And I can have 15 plus 450 will give you what? 1950. I mean now, 1950 minus 200 1750. 1750 minus 40. 1710. So 1710 plus 10. 1720. I have 1720 divided by 50 is equals to what? The h dt. So what is the final answer here? 34.4. 34.4 millimeter per watt second. Is it increasing or decreasing? Eh? Yeah. Oh God. Some people are saying increasing. It's increasing. That's positive. So we've come to the end of this. Not till the end, but calm down. I've not asked you to leave. Just calming down. Let's summarize our notes. Where did we start? We started from today with what? With integration. Okay. Now from integration, I think we did a lot of integration. Even if when we started integration, like 99% of us here were sleeping. Whether somewhere, right? So we did integration. We learned all the methods in integration. I think we did some examples. We did partial fractions, although not all the methods, but we learned the basic methods that we needed to know. And then after that, we move on to application of integration. Then we started with what's it called? Partial derivatives. Then before we treated partial derivative, I think we moved on to what was it that first did? Implicit differentiation first, just to refresh our memory. And from implicit differentiation, the next thing we did was we started by introducing what partial differentiation is. And from partial differentiation, we moved on to what? To higher derivative, yes or no? Second order derivative, yes. And from second order derivative, we move on to what? Total differentials. And total differential is that one that has a weird looking long answers that we had, right? Yes or no? And after total differentials, what else did we do? What else did we do from total differentials? We did chain rule. Yes. How did you know we did chain rule when you're not here? I fear you. So from chain rule, I think I explained chain rule. I explained chain rule using family, and I don't expect that there should be anyone that should forget that formula ever. No one should forget the formula at least. Daddy and son, yes, you can use it as grandchildren. So, except if you don't want to give birth to grandchildren, then that's what you forget. And I think the last one we stopped today was what is this one? Rate of change. So we took some examples. I gave you some formulas, and it looked interesting. Yes or no? Right? Okay. So the next class we meet in place. I just try as much as possible to not to mix it. I said don't miss it. I get in it. Do you know what? The goal is that we are trying to, and we must finish all the syllabus for 2-1 or 2-5 or 3. Okay, a quick notice. If you mix 2-9 class yesterday, you can probably sit down for our 3-1-5 class, which is about to start now, so you can learn also. So yeah, 2-5 and 3-1-5 is the same thing. Yeah. So yeah, it's the same thing. So next time we'll be meeting, we'll be dealing basically with we'll look at extrema. We'll look at I won't teach you Taylor's series of two variable yet. So I don't want it to run away. I'll put that one towards the end. I want to do that. So we'll do a lot of learnings with that. So yes, sir. MVT. Okay, mean value term. Those ones are simple. So nice of that. Yes, very simple. So thank you very much. We have come to the end of today's class. So you can leave. So if you are interested in just round 5 or 2-5, you can remain seated here. That's where we'll start. Interest 305, interest 315 and 25, please. Let's remain seated here. Please, now. The MTS 315. So if you missed MTS 25 class and you're interested in staying, you can quickly sit down and we can continue from where we stopped. But you have to get the notes of the place that we have been. All right. Okay, now. Yes, move forward. So I think so far so good in MTS 315. So please move forward. Occupy the front row. It's very, very important. In exercise round 5, we started by doing some differential equations. I think we started with what? Solutions to what? Differential equations, basically. Yes or no? Yes or no now? That's what we started. Both 315 and 25. I think the only difference is that I moved 205 a little bit ahead of 315 a little bit ahead of 205. We're still the same stuff. So now we started solutions. Are we together? So now this morning, this is what we'll be doing. We'll be testing ourselves, but it won't be like a test. But this is what will happen. All of us, I'll write a question on the board, and all of you will be telling me what I will do. You tell me the method, then we'll continue. I think in 205, we talked about separation of variables. Did we? Did we talk about separation of variables? Did we talk about separation of variables? For those of us that we talked about it. Okay, I think that was where we stopped. Yes, I didn't teach homogeneous in 205. I didn't teach homogeneous in 205. That was 315. So, are we ready? Are we ready? So let's start. So now this time around, as I've said, we'll be dealing with what? More questions. I'll write the question on the board, then what? We'll solve it together. Is that okay by us? All right. So this is the book I used to learn differential equation then. So I deemed it favorable that it would be nice for us to use the book to learn once again. Okay. So now let's start. Separation of variable. Now, question number 1. So this is it. We have what is this? Okay. We have the x over x is equals to tan y dot dy. That means for the next, let's give ourselves time. We can see the time now. We are starting now. So we have started. I just did some probably few introduction of where we stopped. So for the next 1 hour 30 minutes, we'll be just refreshing our knowledge. Not refreshing our knowledge. Let's just continue solving. I think that's good. Now, I want to solve this separation of variable. I want to solve this. Now, and what did I tell you about separation of variable yesterday? 25 and 315. I told you that separation of variable will be written in such a way that x and y can be easily separated from each other. Yes or no? I think that one is attempted here. And I love these people that have helped you with number 1. No stress about that. What do you have to do from here? You have to do what? Just what? Integrate altogether. Integrate both sides. Then by integrating both sides, you can swap it to give you integral of what is that? Tan y dot what? Dy equals to integral of what? Dx over what? Over x. And I hope we know that by now, if we integrate tan y by now, so let me just rewrite it. Tan y is the same thing as saying sine y over what? Cos y dy, which is equals to what is this? If we integrate this one here, what do I have here? I have ln x plus what? Plus c. I remember I told you that whenever you are dealing with something like this, try as much as possible to what? To put your c on another part. I think I said that. Did I not? Now put your c on your what? On your x part. So from here, if you notice that if you differentiate cos y, you were supposed to have minus sine y. But this question gave you what? Sine y. That means that minus that is missing there, you can what? You can introduce it. So minus ln cos what? Y equals to what? Ln x plus what? Plus c. Then, so from here, as I told you earlier on, that whenever you have ln on both sides, what do? You what? Take exponent of what? Of both sides. Now, taking exponent here, I can have exponent minus ln cos what? Cos y equals to what? Sorry, exponent ln x plus what? Plus c. Are we together? Are we together? Are we together? And so from here, please don't, some people usually make that mistake that whenever they see exponential minus ln cos y, they just delete the exponential and the ln, and they write the answer as what? Minus y. Please don't do that. If you do that, you are very wrong. Because this minus here is a power. Do you know that there's an invisible one here? Yes or no? So that one can give me what? Exponential ln cos y raised to power what? Minus 1. Are we getting it? Then this is equal to what? Exponential what? Ln x multiplied by what? Exponential c. Are we getting that? Then this one can cancel out. And don't forget that exponential c is equals to what? Equals to a. So this one can cancel out, and this one give me what? 1 over what? Cos y equals to what? This is x multiplied by what? By a. Yes or no? Then if I cross multiply everything, I can have my answer to be what? 1 is equals to ax cos what? Cos y. Do we understand? Do we understand? Are we sure? Okay, good. Let's look at another question. We'll be increasing the difficulty. Okay. Let's look at this question. I think if I put it in my hand. Now here, number 2, we'll be doing odd numbers. So we have y open brackets. What is this? 1 plus what? X squared is power half dy plus x square root of 1 plus y squared dx is equals to 0. Are we together? So we have something like this. So I told you that if you want mature questions, come and look at HK DAS. So look at this question now. So this question, first of all, it is not even written in the form of dy dx. They wrote it in the way that they what? They splitted it. So now it should not be our own job to arrange it back. Are we together? So let's do that. Now, what do I do first? So since I'm looking for dy dx, then I can take everything here and bring it to the other side. Yes or no? And what will I have? Then I can have, this one is same thing as saying y square root of 1 plus what? X squared dy. Are we getting it? Equals to minus, what would this one give me? Square root of what? 1, sorry, there's x here. 1 plus y squared dx. Now what are you supposed to do here? The thing you're supposed to do is what? You're supposed to differentiate both sides. Not differentiate now. Divide both sides now by dx. So can I have y square root of 1 plus x squared? This is what? Dy over what? Dx. Or rather than doing it like this, can we not move all x to one side? Let's do that. So this is x here. I can swap, that is divide both sides by this one and this one. Then I can have this to be y over what? Square root of 1 plus y squared dy equals to minus x over square root of what? 1 plus x squared dx. Are we together? You get it, what I did? I divided both sides by this and this. Are we together? Then from here, I think it is easier for you to, what? Integrate both sides. So integrate both sides. So if I integrate both sides, I have the integral of what? Y over what? Square root of 1 plus what? Y squared dy equals to integration of what? Minus x over square root of 1 plus what? X squared dx. So as I said earlier on, you must have a very, very vast knowledge in what? In integration. So which integration technique am I going to use to solve this one? Nope. I'm going to use integration by... Yeah, saying the answer already. Say it out loud. Yeah, we are using integration by substitution. Because in this way, there are some questions. This question is written in such a way that you can differentiate to one answer to give you the other one. Yes or no? You can differentiate to 1 plus y squared to give you what? Something that looks like y, if not necessarily y. Are we getting it? That means I can say that let's do both of them simultaneously. I can say that let u equals to what? 1 plus what? Y squared. And let u equals to what? 1 plus what? X squared. So from here, I can say that du is equals to what? 2y dy. Yes or no? And this one here, du is equals to what? 2x dx. Then from here, what can you have? You can have dy, right, is equals to what? Du over 2y. And here you can have dx equals to what? Du over 2x. So then from here, what do I have? Okay, so let's now come back here. And now integration of what? Y divided by, everything here will be what? Square root of what? U multiplied by, what is my dy here? My dy is what? Du over what? 2y equals to, what do I have here? Integration of minus x divided by what? Square root of what? U multiplied by what? Du over what? 2x. And by cancelling, I can have 1 over 2 integration of u raised power minus half du. Yes or no? Do you get that one? You got that? Okay, good. Then this one here should give me what? Minus 1 over 2 integration of u raised power minus half dx, right? It should be dx. Oh, I mean, no, du instead. It's still the same du. Now, so from here, okay, so if I integrate this one here, what do I have? I have 1 over 2. This will be minus half plus 1, which will give me multiplied by 2 raised power half. Happy now? Because to minus 1 over 2 u, multiplied by 2 u raised power half plus what? C. Please do get what I did, please. Do you get what? You know that if you are dividing by integration, it should be 1 over 1, like x to the power, x to the power of n plus 1 over what? N plus 1. And here I have x to the power of minus half plus 1 over what? Minus half plus 1, which is what? X to the power of half over what? Half. And half is the same thing as saying 2 over. Happy now? Happy now? Okay. Where's my clean something? Okay, that's what I have here. So then from here, so what do? I think both of these ones cancel out, right? And I can have what? U raised power half equals to minus u raised power what? Half plus what? Plus c. What is your u raised power half here? This is on terms of your y, so this one is what? Square root of what? 1 plus y squared equals to minus square root of what? 1 plus what? X squared plus c. Yes or no? Yes or no? Then from here, if you take this one to the other side, you can have what? Square root of 1 plus y squared plus what? Square root of what? 1 plus what? X squared equals to what? C. Do you understand? Do you get? Okay, that's our final answer. Okay. Okay. Table of conversion. Which table of conversion? I think the table I gave you didn't have anything similar to this. The ones that I had were ones on top. Yeah, it should be 1. If it were 1 and this one was minus 1, then it should have given you probably sine inverse or cos inverse of x. Now, okay, let's look at this question. So we are dealing with odd number question here. Please just tell me, once you have done 7 questions, we'll continue. Are we together? This is question number 2. Question number 3 here is what? Okay, we have 1 plus x squared dy minus xy dx equals to 0. Are you ready? So what do we have to do first? Take the xy to the what? Take that xy dx to the what? To the other side. And what do I have here? I have this one to be 1 plus x squared dy equals to what? Xy dx. Yes or no? Yes or no, no? Then so from here, I think it is easy for me to what? To swap. And how do I swap? I divide both sides by what they need to. I can just split them. So LA I was to be by y no I was to be by. So what can I have? I have dy divided by y. Yes or no? Equals to what? X over what? X squared dx. Yes or no? I'll get someone trying to say like that. And so from here, what do? You what? Integrate both sides. So I integrate both sides here. So by integrating both sides, how am I circling it like a topic? So by integrating both sides, okay, I think I still have one. So what do I get on this side? Did I finish the last differential equation I was solving with you guys? Yeah, I finished it. Okay, good. So we practice on homogeneous more. She got on branches like that. Practice more on it. Don't worry. By the time you enter, yes sir. Eh? Sir? No, it's not homogeneous. I'm just like giving us, you know that I promised us when we were doing 2 round 5 that we'll do more questions. So I'm just doing more questions so that we can brush enough, sharpen up our skills. Do you get? So after this, we continue to homogeneous. So from here, this is what will happen. So I think, so by integrating both sides, what do I have? I'll have integration of what? 1 over y dy, right? Equals to integration of what? X divided by what? 1 plus what? X squared dx. Yes or no? Then by integrating both sides here, this gives me what? Ln y equals to what? 1 over 2 ln 1 plus what? X squared, plus c. Yes or no? Right? So please, I told you have to go and master, sharpen your skills on what? On integration. You need it. You need it a lot. That skills must be what? Must be sharpened. So because I might not really have the time to be going back to teach you what? Integration. She got trying to say like that. So now, so from ln y here, so I told you that whenever you have ln on both sides, what do? You take exponents. Now taking exponent of this side, I have what? Exponent ln y equals to what? Exponent half ln, what is this one? 1 plus x squared. I hope you believe that I can immediately split this to give me exponential c, straight up, without stress. Yes or no? I be now. So from here, I can have what? Y equals to, this half can come back here to give me what? 1 plus x squared raised by what? Half multiplied by what? A. Are we getting it? Are we getting it? Then from here, I think it is better so that if I square both sides, to squaring both sides here, what will I have? I'll have y squared equals to what? 1 plus x squared multiplied by what? By a. Then this will give you what? Your final answer. You get what I'm trying to say like that? So now the next one here is question 4. Please, are we getting it, please? Good. So question 4 here, we have y sec squared x plus y plus 7 and x dy dx equals to what? 0. Alright, we have something like this. So first thing first that we have to do is that from this question, let's find a way to what? To manipulate it. So let's pick all these ones and throw it to what? To the other side. Now what do I have here? I can have y plus 7 tan x dy dx equals to what? Minus y sec squared x. Are we together? Are we together? Then so from here, you can do what? So we can split them and shade them together. So by splitting and sharing, what will I have? I think I will have y plus 7 divided by y dy equals to what? Minus sec squared x over what? Tan x dx. Have you now? Then from here, what do? I would integrate both sides. So by integrating both sides here, what do I have? I now have integration of this y. I can have it as what? Y divided by y plus 7 over y. Yes or no? dy equals to integration of what? Minus sec squared x divided by what? Tan x dx. Yes or no? Then this one is the same thing as saying integration of 1 plus what? 7 over y dy, which is equal to what? Minus ln tan x. I'll be now plus c. You know why it's minus ln tan x? Because the minus here is here, and if you differentiate tan x, you have what? Sec square x. And there's a differentiation that says that if you have that kind of law, that if you differentiate your denominator and you get your numerator, the answer will be what? ln of your what? Denominator. You got what I'm trying to say like that? Okay, good. So from here, if I integrate 1 here, what do I have? I have y plus what? 7 ln y equals to minus ln tan x plus what? Plus c. And there are a lot of ways you can do this one, a lot of ways, but this time around I choose to bring this one to the other side. And my answer here will now be y plus what? 7 ln y plus what? Ln tan x, are we together? Equals to what? C. Then from here you can have y is equals to, let's just leave it like this as a final answer. No stress. Do you get it, please? Show you what? Please, if you don't understand, talk. Do you get, please? Okay, I hope you got that. All right. Okay. That's question what? Question 4. We are going to question 5 now. So question 5. Now question 5, we have dy dx equals to exponential x minus y plus x squared exponential minus y. So this is what you have. So now in this scenario, it looks like, how I call it, it looks somehow devilish, Abi now. It looks like something that cannot work. No, the thing is that don't let the question scare you. Scare the question yourself personally. Get. Now the thing you do here is that first things first, you can write this equation. Yes or no? So let's rewrite it. So I can say that the y dx here is equals to, writing this equation here, what do I have? I have exponential x multiplying exponential minus y plus x squared multiplying as what? Exponential minus y. Are we together? Then everything here is the same thing as saying dy dx is equals to what? Exponential x over exponential y plus x squared over what? Exponential what? Y. I've gotten it. Then from here, let me bend. What do I have? I can have dy dx is equals to what? Exponential y as your LCM. And what do I have? Exponential x plus what? X squared. Yes or no? Then by cross multiplication, I can have exponential y dy is equals to what? Exponential x plus what? X squared dx. Then from here, what can you do? You integrate integrate both sides. So by integrating both sides, what do I have? I have integration of what? Exponential y dy equals to integration of exponential x plus x squared dx. Yes or no? Then if we integrate exponential y, what do I have? Exponential y equals to exponential x plus x cubed over 3 plus what? Plus c. Have you now? That's the final answer. Number 6. Okay, let's draw the curtains here at question 5. Let's enter homogeneous. Let's enter homogeneous. How it's gonna? Let's enter homogeneous. So I started homogeneous yesterday with 315. So 205. I'm starting homogeneous together at the same pace. So, homogeneous differential equation. So, number 1, let's solve, what's this now? Okay. I want to solve x squared dy plus y open bracket x plus y dx equals to what? 0. So I want to solve this. So by solving this one, this time around, what will I have? So it's homogeneous. Now, how do we recognize homogeneous? Let me quickly tell you that. So now, homogeneous can only be written, they are written in such a way that neither x nor y can be able to be separated from each other. I guess what I'm trying to say like that. They will write it in such a way that you cannot remove y from x. I guess what I'm trying to say like that. Now let's look at this example on the board. Can I remove y from x? Eh? Can I? Are you sure? Very sure? I don't believe. But let's do it together. So for me, it's obviously that there's no way I can remove y from x, because each time I open this bracket here, I'll still have what? An xy. Are you getting it? So from here, just try as much as possible to first of all get your what? Dy dx from this place first. And I can have here to be x squared dy equals to minus y x plus y dx. Yes or no? Then if I divide both sides by dx, you can have what? X squared dy dx is equals to what? Minus y open bracket x plus what? Y. Are we getting it? Then from here, I can say that your dy dx here is equals to what? Minus y open bracket x plus y divided by what? X squared. Are we together? And whenever you have something like this, the next step you are going to do will be let y equals to what? Vx. That's a substitution. Substitute y equals to vx. This is what? Homogeneous. Homogeneous. So now let y equals to vx. Just asterisk this formula. And so I can answer that dy dx here is equal to, so let me open this place with y first. So I have minus xy, right? Plus, what is this? Y squared divided by what? X squared. Yes or no? Okay, sorry. Minus y squared. And for me, what do I have? I have minus x open bracket what? Vx minus what? Vx all squared divided by what? X squared. Are we together? Then dy dx here is equals to what? Minus vx squared minus v squared x squared divided by what? X squared. Yes or no? What don't you get? How did I get this one? This one here. Then I said that after this, please. This one here. And now x times vx, x times v, x squared. And this one all squared. Immediately my b squared me by. Figure. Now, so from here, I think it's easier for me to factorize. Let's factorize what do I have here? X squared here. So I have dy dx here equals to what? Minus, don't know. X squared will give me what? Minus v squared. Sorry? Minus v squared divided by what? X squared. Yes or no? Then so from here I can have what? Dy dx is equals to what? Minus v minus what? V squared. Do you get that? And so from here, what do I do? So now from here, I've gotten to another threshold. I can now say that recall that y is equals to vx. Then from here, differentiate. So I want to differentiate this answer. So if I differentiate y, what do I have? Dy dx. I'm getting it. Equals to this one here. I want to differentiate vx. Then how do I differentiate vx? I can differentiate by using product to u and what? And v. So using product to here, what will I have? U dv. So which is what? V. Differentiating x will give me what? 1 plus right x. If I differentiate v, what do I have? Dv dx. Do you get? Then from here I can have, let me come down. I have dy dx is equals to what? V plus x dv dx. So this is another equation. So instead for me to use dy dx here, what will I use? I can use what? V plus x dv dx. So substituting this back inside this formula. So what do I have? I have v plus x dv dx is equals to what? Minus v squared. Are we together? And so from here, take this v to the other side. Then you have x dv dx equals to minus v squared minus v. Right? Then here you can have x dv dx equals to what? Minus 2v minus v squared. So from here, So from here, I think, okay, let me do it this way. So from here I can have x dv dx is equals to, if I factorize with minus here, what do I have here? 2v plus what? V squared. I'll get what I'm doing, please. Have you now? Okay. Then from here, now the next step I can do here is what? Let me split them into 2. So by cross multiply, I can have what? X dv equals to what? Minus 2v plus what? V squared dx. So let's divide what they need. So I can say that 1 over 2v plus v squared dv is equals to minus 1 over x dx. Yes or no? Yes or no? Okay, good. Now the problem now I have is, how do I differentiate this fine borders? How do I integrate it?
Should I zoom out? Or is the...
Now before I go there, so let's go on and say that we do what? We integrate both sides. So by integrating both sides here, so what do I have? I have integral of what? 1 over 2v plus what? V squared dv equals to what? Integral of what? Minus 1 over x dx. Yes or no? Now question is remains, how do I differentiate that?
Is zoom okay now?
So I think the best way to differentiate this is to carry this on to partial fractions. Have you now? Okay, let me isolate this one first. Let me remove this one now. So I have 1 over this v here is the same thing as saying v open bracket 2 plus v, right?
What about the back?
This one is equivalent to saying a over v plus what? B over what?
The
2
back of
plus
the
v,
audience and
right?
the other chair by the right.
Then from here I can say that 1 over v open bracket 2 plus v is equivalent to a multiplied by 2 plus v plus what? B multiplied by v divided by v open bracket 2 plus what? Plus v. And from here, what do I have? I have 1 equals to 2a, Abi now, 1 equals to 2a plus av plus what? Bv. Then from here, if I want to compare, I can say that 1 equals to 2a plus v open bracket a plus what? Plus b. All together. I don't have any function of v on the other side, so if I compare, I can say that 2a is equals to 1, Abi now, and the next one, a plus b is equals to what? 0, right? Then from here, I can have a here is equals to what? 1 over 2. Then if a is equals to 1 over 2, definitely b here is equals to what? Minus 1 over 2. Yes? And I've gotten a and b, so the next thing is what? Come back here and come and write in. So we write in this one here, what will I have? And I can have 1 over v open bracket 2 plus v is equivalent to, now this a can come outside to give me what? 1 over 2 multiplying 1 over v, right? Minus 1 over 2 multiplying 1 over 2 plus v. Yes or no? Yes or no? Then so from here, substitute this answer back inside this question. So from here, you can now have integration of what? 1 over 2 open brackets 1 over v minus 1 over 2 open brackets 1 over 2 plus v, everything dv equals to what? Integration of minus 1 over x dx. So from here, if we integrate this one, I have what? 1 over 2 ln v minus 1 over 2 ln equals to minus ln what? X plus c. Are we together? Then this half, if I want to, okay, let's say I want to factorize half. So removing half here, I have what? Ln v minus what? Ln 2 plus what? V. Then equals what? Minus ln x plus what? C. And from here, take the powers. I can have half, open bracket, ln v over 2 plus v. Yes or no? Yes or no? So from here I can have ln of x to the power of minus 1 plus what? Plus c. Yes or no? Then so from here, let this half come back. So I can have ln open bracket v over 2 plus v divided by what? 1 over 2 equals to what? Ln x minus 1 plus what? C. I told you that whenever you have ln on both sides, what do? You introduce exponential. So if I take exponential on both sides, so exponential ln v over 2 plus v raised to power half equals to what? Exponential ln x to the power minus 1 multiplied by exponential c. Yes or no? So everything will give me what? V open bracket 2 plus v, everything raised to the power half equals to what? 1 over x a. Abi now? Then from here, what do I have to do? Square both sides. So if I square both sides, so I have v over 2 plus v, Abi now, equals to 1, or let me say equals to a over what? X squared. Are we getting it? But don't forget, I can only answer in terms of what? In terms of v. Are you getting it? I cannot even answer in terms of v because my question was not given in terms of v. My question was given in terms of what? X and y. So I can now say that recall that y equals to what? Vx. And from here, v is equals to what? Y over what? X. Are you getting it, please? Then the next one that we have here. From your heavens and the So, okay. So now if I now substitute this answer back inside this space, what do I have? And I have what? So I have y over x, divided by 2 plus y over x equals to what? A over what? X squared. Then from here I can have y over x divided by 2x plus y over x equals to what? A over what? X squared. Yes or no? Good. Then from here I can have y over what? 2x plus y equals to what? A over what? X squared. Abi now? You know how? Division will change up, then x will cancel x. And I think the best way for me to write is to a equals to what? X squared y over what? 2x plus what? Y. That's my answer. It's very long, sorry, but you must know it. Each kid has. Okay, I'm coming. I'm waiting for us to finish writing. If you ask a question, you can ask me. Alright, so question 2. Alright, are you ready? I'm going to first finish writing. Right, right. Let's be fast. By God's grace, we should be able to finish solution of first order differential equation today. We should. It depends on you, not me. Yeah. I'm ready to teach you. Very, very ready. Always ready. Very, very ready. Ready? Can we start? Are we sure? Can we start? I need full response. Okay, good. Now from here, so I think this one should not be a problem to us. Do you know why? Now, straight up from here, first thing I want you to know is that, first of all, your dy dx here, if you, please, there are some cases that you don't necessarily need to show the province of the workings. You can just know that. Don't worry, just know that your dy dx is equal to what? This solution. As I said, let me box it for you. Know this as your solution. Know this also. Then know this too. I'll go to my friends like that. Eh? Yeah, for all cases, as long as it's homogeneous, they will help you out. And I think I told you how to recognize homogeneous. They are written in such a way that you can never separate x from what? From y. So from here, are we together? Now from here, without stressing ourselves, if I look at that formula that I draw arrow to the top, I can find out that my dy dx is also equals to what? V plus what? X dv over what? Dx. Are we together? Okay, good. And also, you can notice that v is equals to y over x. Yes or no? That means I can substitute these two values inside this place straight up. So what will I have here? I can have v plus x dv over what? Dx is equals to, what is everything here? V plus what? X sine what? Sine what? Sine v. So this time around, so how do we do it? Let me come up here. How do we deal with this? So from here, I can now say collect like terms together, take v to the other side, and you can have what? X dv dx is equals to what? V plus x sine v minus what? V. Then you have, have x dv dx is equals to what? X sine v. And how do I do this? Differentiate both sides now. Have you now? If I differentiate both, cross multiply first. Or first, yeah, let's cross multiply. So I have x sine v dx equals to then x dv, right? Then bring x to the other side, then you can have x dx over x equals to what? 1 over sine v dv. Yes or no? Then so from here you can have, what is this integration? That will give you what? That's 1 dx equals to what? 1 over, so what is 1 over sine? 1 over sine is what? Cosec. Cosec what? V dv. And so from here you can have integrate both sides. So from integrating both sides, what do I have? I have integration of 1 dx also what? Integration of what? Cosec what? V dv. So if I integrate 1 dx, what do I have here? I have x equals to, now what will we get if we integrate cosec x? Do I know the answer? So if you integrate cosec, the answer, if you don't know before, is ln tan y. Ln tan v. So you get, if you don't know before, know now. So from here, I think I told you where your c will be. Where will your c be? Beside x. So this one can now be written as x plus c equals to ln tan v. And don't forget that v is what? Y over x. Then final answer will now be what? X plus c is equals to ln of what? Tan y over what? X. So that's that about that. There we get another question. Number 1, we have y squared minus xy dx plus x squared dy equals to 0. Are we together? How many start? Are we sure? Okay, good. So from here, this is the question. So let's work with this question. So first thing first, we have to try to write the question in such a way that I can have my dy dx, first of all. So now, so let me take everything I have here to the other side. Taking everything I have here to the other side, what do I have? I can have x squared dy equals to, then I will have minus open bracket, y squared minus xy dx. Yes or no? Yes or no? Yes or no? Okay, good. Then from here, I can now have x squared dy. If I open this bracket with minus, I can now have this one to give me what? Xy minus what? Y squared dx. Yes or no? I mean now, if I expand this one with minus, then divide both sides by dx, then I can have x squared dy over dx equals to what? Xy minus what? Y squared. Then taking this one to the other side here, so your dy dx here is equals to what? Xy minus what? Y squared over what? X squared. Are we together? So look as if you can separate y, but you cannot separate y. I be now. So now, don't forget, what are you substituting? Let's write it y equals to what? Vx. Then putting that here, so your dy dx here will give you what? X multiplied by vx minus, what do I have here? Vx all squared divided by what? X squared. And from here, dy dx is equals to what? X, sorry, not x, sorry, vx squared minus v squared x squared divided by what? X squared. Then from here, what do I have? I have dy dx is equals to x squared, open bracket, v minus v squared divided by what? X squared. This one will cancel out. So I can have dy dx is equals to what? V minus what? V squared. Then I can also remind them that but dy dx is also equals to what? V plus x dv dx. So therefore, then this one will now give you 4 plus x dv dx equals to what? V minus what? V squared. Are we together? Then taking this one to the other side, so you have x dv dx equals to what? V minus v squared minus v. Then what do I have here? I have x dv dx equals to what? Minus v squared. Then if I divide both sides, then what do I have? I think I have I might have 1 over v squared dv equals to minus 1 over x dx. Then for me, I can do what? Integrate. I can integrate both what? Both sides. So by integrating both sides here, what do I have? Then I hope you know that this one is going to be v raised by minus 2. If I integrate v raised by minus 2, what do I have? I have minus 1 over v equals to, what would this one give you? Minus ln x plus what? Plus c. I've just integrated it straight. Then I think, don't forget here, what will happen? What is your v? So your v, I can say that minus 1 over y over x, which equals what? Minus ln x plus c, and your final answer should be minus x over y equals to what? Minus ln x plus c. So you can write it any how you want to write it, but let me leave my own answer like this. So, okay. So, one more question or we should move on. One more question or we should move on. Okay, let's go one more question. Okay. Alright, so let's look at this question. So then we have x squared minus y squared dx is equals to 2, sorry, it's not equals to here, plus 2xy dy equals to 0. So from here, let's start. Take this one here to the other side. Then what do I have? I have 2xy dy equals to what? Minus open bracket what? X squared minus y squared dx. Yes or no? Then from here, what can I have? 2xy dy equals to what? Use minus open bracket, which will give you what? Y squared minus x squared dx. Yes or no? Then divide both sides, so I can have 2xy dy over what? Dx equals to what will I have here? Y squared minus what? X squared. Are we together, please? And so from here, divide both sides by this, so we have dy over dx equals to what? Y squared minus x squared divided by what? 2xy. And from here, let what? Y equals to what? Vx. I'm putting that back here, so you have dy dx is equals to what? Vx all squared minus x squared divided by 2x vx, and everything should give me what? V squared x squared minus what? X squared over, what will this one give me here? 2v x squared. Then your dy dx equals to, what do I have here? I think I have x squared common, then which is what? V squared minus 1 over what? 2v x squared. X squared can cancel x squared. Are you following me, please? Then what can I have? I have dy dx is equals to what? V squared minus 1 over what? Over 2v. Then here I can now say that, but what happened? Dy dx is also equals to what? V plus x dv dx. Therefore, what do I have? I have v plus x dv dx equals to what? V squared minus 1 over what? Over 2v. Taking this on to the other side, so you can have x dv dx equals to what? V squared minus 1 over 2v minus what? V over 1. Then I have x dv dx equals to square root here is what? 2v, which will give you v squared minus 1 minus 2v squared, right? Then so from here I can have x dv dx, which is equals to minus 1 minus what? V squared over what? 2v. So I hope you know that I can write it as x dv dx as what? Minus open bracket 1 plus v squared over what? 2v. Yes or no? Then from this part, if you cross multiply, then you can have 2v over 1 plus v squared dv equals to minus 1 over x dx. Yes or no? Eh? Okay, good. And from here, what can I now do? I can what? Integrate both sides. So by integrating both sides here, what do I have? I have an integration of 2v over 1 plus what? V squared dv equals to integration of minus 1 over x dx. And at the end of the day, what will I have here? I think I'll have ln of what? 1 plus v squared equals to what? Minus ln of what? X plus c. Then if I exponent both sides, then I can have what? 1 plus v squared is equals to a over what? X. But also remind them v is equals to what? Y over what? X. So if I substitute the answer there, then from here, so if I put that back here, so what do I have? I have 1 plus, what is this? Y over x, everything here is squared, equals to what? A over what? X. Then I can have this one here as y squared over x squared equals to what? a over x minus 1. Yes or no? So multiply everything by x squared. So I have y squared is equals to what? Ax minus what? X squared. That's the final answer. Do we get? Do we get? Do we get? From where? From where? This side here. And now, from here, v is equals to y over x. Then put y over x inside this formula here. Then take 1 to the other side here. Square both sides, then you have this. Shake grab. Okay, so that will bring us to that. That will bring us to the end of what? Homogeneous. Now let's look at the next one, which is what? Exact. Now, geez, why am I jumping to exact? Linear differential, linear DE. So let's look at linear DE. I want to look at linear differential equations. Sorry, am I too fast? Ah, sorry, boss. Why can't you tell me that I'm too fast? Since I'm eager to finish the course with you guys. I want to see your happy faces in your test. The fact that I see questions and you'll be happy to solve. That's what I want. That's why I'm rushing. Not like rushing. But you should understand what I've been doing since morning so far now. Okay. Alright, this might be fast. I still be the same thing. So now exact. Alright. Please let's write fast so that we can conclude. Which part? Okay, want to see it? Okay, sorry. So after we are done with first order, we still have a long way to go. A long way to go. Okay, sorry. Why can I now stay like this? I mean, they do, I'm not scared. This thing when I did snap, sure I will gather, go read down like this. Oh, sorry. Maybe it's better I don't exist on the board. I'm disappearing. I'm waiting for also. So please run next to after round 5 for yourselves and come. So let's run the race, let's win. Are we done writing? Alright, can we start? Alright, good. Nice. Love that. Okay now, so linear differential equations. Now how do you recognize that they are linear differential equations? First thing is that all linear differential equations are written and once you create a format. Once you create the format, then the next thing we'll now do will now be how to solve using the format that we have created. Are you ready? Okay, good. Note, all linear differential equations are written like this. dy dx plus p of x y equals to q of x. This is all linear differential equations. I get what I'm trying to say like that. This is how they are written. As long as it is linear, this is how you will find them. Integrating factor in exact. I mean, why am I saying exact? There's something called integrating factor in linear differential equations. So integrating factor is if, and it is denoted by this formula, exponential raised to power p of x dx. Factor equals to what? Your q of x multiplying your what? Integrating factor. Yes or no? Yes or no?